I don't know if you're doing anything
Oh,
in prep.
no, I'm just
Michael's
waiting on
doing
Michael. Welcome back, everybody. Warm welcomes back after lunch. My name is Stephanie Addis. I guess I could say I wear many hats. I was a former Pitcher resident, grew up there with my grandparents. Later on, moving to Quapaw. Long story short, I'm now an activist for Tar Creek and a steward to our land. Still in the learning process, and I don't think that it ends. So I'm just extending my gratitude and my gratefulness to this gathering and everybody here today. I am going to ask us to, I know we just came back from lunch, and I also, one of my many hats is a yoga instructor here in this area. My passion with that was to develop coping mechanisms to combat, I guess you would say, effects of lead, to manage stress and anxiety. So this is deep in my heart, so bear with me. But so I know we came back from lunch and everyone's settling in, and we're just going to do a couple of belly breaths. So if I could just get you to participate with me, this will just take maybe 1 minute. I kind of came up here with, no speech rope. So this is what I like to do. So we're going to set up nice and tall through our spines. Maybe take your back off the backs of the chair. Going to plant both of the feet, the soles of the feet into the ground. And just lay the hands wherever they are comfortably. Maybe softly close the eyes and the lips, because we're going to be doing some nasal breathing. So we're going to start taking a nice inhale through the nose, and we're going to fill up the belly, the last part of that breath, filling the chest, open up, and then exhale through that nose fully, completely, pulling that navel back towards the spine, really releasing that exhale, releasing any tension in the body, releasing any future or past thoughts, and just being here for this gathering. And go ahead and take another deep breath and just continue this passive breath for just a cycle or two if you really like the feeling of it. And whenever you're ready, just softly open the eyes and come back to the room. So this is just a little bit of coping mechanism that I've developed growing up in Pitcher. It was really hard for me to paint the story of how the past has affected our present and will continue through the future if we don't take action. So it's called belly breathing. You can look it up on YouTube, and it's some good kind of restorative for the nervous system. So I'm going to introduce Mariah, and she's going to come up here and take my spot.
All right, thank you all. I just want to share a little bit about some of our children and youth programs that we've done with LEAD, and particularly a petition that was created by children and youth in Ottawa County. So in the summer, LEAD hosted an environmental activist camp for children and youth, and it was such a meaningful and fun experience. And I had the incredible opportunity to get to help facilitate that camp, but also get to learn with a lot of just really inspiring and thoughtful young people here in Ottawa County. And the children and youth who attended, they got to create a project that they wanted to do to try and make a difference in their community. And what they decided to do was to create a petition. And so they did a lot of research. They interviewed a local resident about their experience with flooding, and they actually drafted and created this petition, which is available online as well. And so if you look around the room at different points, there are these posters, And you can scan the QR code and then sign and share the petition. And so I just wanted to emphasize how meaningful it would be to the children and youth if you took the time to sign the petition and share it and get the word out and help to raise awareness through this petition and validate all of the incredible and thoughtful work that they put into creating this. The petition? Do you want me to read the, okay, yeah. So this is the petition that they drafted. And again, they drew on past publications that LEAD has produced and internet resources and lots of other materials. So, quote, "As I watched the water get closer and closer to my house, it reminded me of how my innocent childhood was gone and how fast I had to grow up." End quote. Join us in convincing FERC and EPA to work together to stop unnecessary and toxic flooding in northeastern Oklahoma. Help protect our communities by signing our petition and sharing widely. We are a group of children and youth who attended LEAD Camp 2023. We live near the Tar Creek Superfund site. We and our families, friends, and neighbors are directly affected by the combination of flooding and the Tar Creek Superfund site in Ottawa County, Oklahoma. A camper's relative whose house was lost to flooding said, quote, "I'm self-employed and I had no kind of medical insurance at the time. I couldn't go see a therapist, you know? I went down kind of a dark road because I felt like everyone had turned their back on me." End quote. The Pensacola Dam was opened in 1940, and since then communities upstream of the dam have experienced extreme flooding. When there is heavy rain, Grand Lake floods and the water backs up, flooding communities upstream. This is called a backwater effect. The backwater effect can be prevented by lowering Grand Lake water levels and practicing better water management. The floods are man-made and the floods do not have to happen. Many of the properties along Grand Lake are wealthy vacation homes, but the communities that flood upstream are often low income. Even highly valued homes in Miami, Oklahoma lose property value due to flooding. The land that floods is made up of the territories or homes of the Quapaw, Seneca Cayuga, Miami, Modoc, Wyandotte, Ottawa, Peoria, Shawnee, Eastern Shawnee, and Cherokee nations. Additionally, strong Micronesian and Latinx communities live here who are impacted by this flooding. This is an environmental justice issue. We also live near the Tar Creek Superfund site, a former lead and zinc mining site. When it floods here, mining waste from the Tar Creek Superfund site spreads to surrounding bodies of water, flooding us with toxic and contaminated water. The EPA is responsible for cleaning up the Tar Creek Superfund site, but they are not currently involved in dam regulations. GRDA, the state agency responsible for operating the dams, refuses to help us. Tar Creek's toxic flooding is an environmental protection issue, and we need the EPA's help to protect our communities. We are asking the EPA and FERC to stand up for our communities by working together in dam relicensing and water management. Quote, "My house was underwater. We had no place to go, nothing to eat. I lost all my clothes and food. The flood affected my daily life. I was not living right, not eating right. It's just not the same." End quote. Help stop unnecessary flooding and the spread of mining waste that is devastating our communities and damaging people's lives. Take action, sign and share our petition today. And I just want to reiterate, this was researched and drafted by a group of children and youth. I think the oldest person who participated was in 9th grade. They were incredibly inspired and motivated and enthusiastic to share their stories and to talk about how they were personally affected by this flooding. And I can't express how much it would mean if you would, sign and share and raise awareness about the incredible work that they did and thoughtfulness that they put into crafting this petition.
You had the opportunity just now to meet Mariah Bailey Stevenson, who is an activist, and we are thrilled that she's working with us, especially working with children here. I'd like to invite Leka, the Cherokee's representative, Debbie Dodson, and are you president of the board? Yes. I thought so. To tell you a little bit about the project they have just completed. Thank you.
Alrighty, I don't have anything as inspiring and as heartfelt as stories of real life experiences of children, but I'm glad to be here representing our watershed group, and also I work for the Eastern Shawnee Tribe of Oklahoma. I'm water quality officer there, and those of you that work for tribes or are familiar with tribes, you know you have to wear a lot of hats. You know, you might be given totally different workloads from day to day sometimes, but one of those things that I've been participating in is our Lake of the Cherokee Sub-Watershed Association. We're a fairly new fledgling group. We are nonprofit status, and we do have a watershed plan for our watershed. That was the big push to form the group originally, and now we're just trying to create more awareness within the watershed. So you can see this is that old map from Oklahoma Conservation Commission. I've used this a lot. But you can see I think it's about 70% of our water in Grand Lake actually comes from Kansas. So you can see all the way up in northern Kansas, that's where the Grand Lake watershed starts. And then over on the Missouri side as well, Spring River feeds in from the Missouri side, goes across the state line into Kansas, and then down into Oklahoma. We've even got a little bit of Elk River down in Arkansas. So it really is all 4 states, a couple different EPA regions. I don't know how many more boundaries you need for people to work with, but sometimes that's challenging. Another part is, you know, we've got the 9 tribes in Ottawa County in the Oklahoma part, but we're in the lower section. And part of the watershed group focus is not just Grand Lake itself, but how do we get there? So this is a portion of the Grand Lake watershed called the Lake of the Cherokee Sub-Watershed, and you can see parts of it are in Missouri, parts of it are in Kansas, in Oklahoma, a little touch into Arkansas there, and that's the way our board members look as well. Our members are, some people are Kansas, some people are Missouri, some people are Oklahoma. We've got a couple tribes represented, some retired people, some people that work for a living, some people are educators. So it's a pretty diverse group. I really like that. I like working with people from different backgrounds. I learn a lot more from people that don't do the same thing I do. So, and we try to work together. And our big push is to create awareness that Grand Lake is not just the water that's in Grand Lake. It's the water that feeds in from upstream. And like I said, the biggest portion of the water in Grand Lake comes from Kansas or Missouri. And we'd like to work into doing some best management practices. We've completed a couple of small grants so far, and we're looking for another one, hopefully with some funding to actually implement either a best management practice on the ground or a workshop or teaching tool to encourage other people to do the same. So we started out just looking for the watershed plan as our framework to build on, and we have a really good watershed plan. I'll get to our website in a little bit, but you can see I like this map. This is from Model My Watershed, and it shows all the little towns involved just in this portion, that it does include Grand Lake at the bottom, but it includes all these small towns and areas, including Miami and over in Seneca in Missouri, Wyandotte, and all the way down to Disney and up into Kansas. And like I said, we've got members on our board from all those areas. And so we were trying to think of ways that we could approach people to let them know that they are part of the Grand Lake watershed and there's something they could do as an individual, and especially if there's an educational opportunity where we could hopefully inspire people to think twice about what they're doing to their neighbors downstream. So our stakeholders is about anybody. We're not very discerning on, I guess, we don't have a checklist. You have to qualify to be on our rolls. So if you're a stakeholder and you want to attend our meetings, so basically I usually say if you live, work, and play in the Grand Lake watershed, come to one of our meetings. And most of those are by Zoom, have been for the last couple of years, obviously, but and two, because some of our membership is pretty spread out. So we started in 2020. We got a Bureau Reclamation Water Smart grant, and that paid for creating the watershed plan. There's a lot of science and research included in that, and it's something we had to hire a professional consultant to help us work through that. We established our bylaws and elected officers. Our watershed plan was approved, and we got our 501c3 status, so that made us eligible for some grants. We've got a brochure out there and a website and a Facebook page, so we're trying to get a little bit of visibility, kind of on the cheap, but so this is what our brochure looks like inside and out, and that's our website. So if you go to that website, there should be more information that you can actually link to, and just a little bit more about who we are. This past year, we got a small grant. It was an EPA grant originally that we got a $4,000 grant to do signage, awareness signage. So we wanted to put signs out along the roads, particularly on the bridges of the waterways in our area, to say this water goes into Grand Lake. And we selected a lot of locations. We kind of went back and forth over where do we put them, and then we designed this really nice sign. And Oklahoma said that's too fancy, it'd be distracting for drivers. So X the nice sign with the nice design, and go with more direct. So the Spring River one is actually one of the sites where I sampled. It's there at Highway 10. If you're local, you know that is Moccasin Bend. And I had to have my intern run up the steep hill this summer because I didn't want to park on the side of the highway and try to get a picture. So he ran up the steep hill for me and took the picture. And but you can see these signs. The Horse Creek sign, that's in Afton. So we've got signs distributed all throughout the watershed. We've actually got a few signs left over. And like I said, they're very simple. There's not really a direct connection back to our watershed group like the original sign that was, a lot prettier. But the highways, ODOT says it has to be very direct. So, okay. And they actually put the signs up for us, but we just had to buy the signs. We also have a billboard. If you're going east out of Tulsa, you get close to Miami, get close to exit 313, it's on your right. And it's kind of nestled in some there's some trees in the background. But this is another sign that we participated with, and then we're trying not to be political in any way or affiliated with anybody, but we do have to work together with other agencies sometimes. And so we are, like I said, just trying to let people know that when you're driving in through here, this is the Grand Lake watershed. We did a couple of outreach events this year, which was really fun, and we hope to continue more things like that, either workshops or educational things for, I like working with kids. So like I said, the top picture is some kids that are at the Shoal Creek Water Festival, and they're coloring some wooden fish. And we had several people come by, and we've got our nice fancy banner there that we ordered. You can use it as a banner or a table cover, depending on your event. We also did an Earth Day event in Grove, And like I said, we're looking for more events that we can attend. And we usually have a big watershed map with us too, because nothing said it better than a picture. And I'm kind of a map nerd anyway, so. We've got some extra signs left, so I'm looking at getting a couple over on the Missouri side. Lost Creek particularly is right there in Seneca. And I know Jim Triplett from Kansas was looking into talking to KDOT to see if they would work with putting some signs up on their bridges as well. Because like I said, there's a lot of people in Kansas that have no idea that the water in their backyard is part of Grand Lake. And there's people right here in Miami that probably don't know that their water in the backyard ends up in Grand Lake. So that's the whole purpose of the project, is just to encourage people to think more about where they live, where their water comes from, and where it goes. So future plans, we're hoping for some landowners that want to participate in a project. That's either to host a field day or a workshop. Looking for more input, and if you want to represent yourself or somewhere that you work, that you have interest in clean water, I think that's about everybody. We'd like to hear from you and would like you to participate with us. Looking for funding partners for local projects and more outreach events to promote our efforts, and grants for nonprofit or watershed groups. Nonprofits are a little easier to find than watershed groups a lot of times. There's not a lot out there to help fledgling watershed groups do a lot of work. So that's us, our board members. We just ask that you care about the future of the watershed. We have regular meetings every 2 months. You can share your personal or professional knowledge. Some people specialize in education. Some people specialize in BMPs or technical skills. We have a retired NRCS person on our board, and we have Grant Victor. He's on something with Oklahoma Conservation Districts. He's on a national scale for Oklahoma. He's the Oklahoma representative. But so people like that know people. That's also really helpful. And you just try to stay current on things happening in the watershed. We've got a lot of things going on that are positive that don't get a lot of highlight. So we'd like to highlight those more, either our website or our Facebook page. So feel free to share those things with us so we can put those out to the public. So that is our website. And we've got an email address, and you will get a response. Edie Wiley, she's our secretary, and she was actually going to be our presenter today, but she could not make it. But she's kind of the herder of the cats, because we're not always the most cooperative group of random people, so it's hard to get us coordinated sometimes. But she's always keeping us in the loop, and she follows up on every email. And like I said, if you have something you'd like to share with our group, or if you'd like to come and just see what it's like, you're welcome to come to one of our meetings. I usually post those on Facebook, or if you email Edie, she can give you the date. I think our next meeting is November 9th at 2, and there'll be a Zoom link go out for that. But like I said, we've got more signs. We'd like to finish using those up, and hopefully we can get cooperation from our neighboring states, so we can go a little further than just Oklahoma. But I told you I was a map nerd, so there you go. These are the water basins of the United States, and you can see ours is right in the middle of the big one. And so I think that makes us pretty important in protecting our water quality. And like I said, as water quality officer, I'm usually I'm the field person, the lab person, and the data person, and the grant writer, and the kind of the all duties as assigned. I know it works that way for a lot of tribes. They don't have a lot of staff, maybe for their environmental department. but it's something I really love. Education outreach, definitely something it's a perk for me. I know a lot of people think it's a pain, but I really enjoy working with young people specifically, but people in general. And water's become kind of my passion as I get older, and then I think I'll always stick with water on a professional level. And so working with the watershed group, you know, that kind of falls into my work hat and my personal hat, and we'd like to keep that going. And we do have some good sampling news for this fiscal year. Eastern Shawnee Tribe received some funding to do some floodplain soil sampling in the area, and some additional metals and fish sampling from like Tar Creek and Elm Creek. We'll probably be on the banks down here by NEO getting our soil samples and our fish samples, and that'll be probably in the spring. I'm not going out in the winter, but anyway, I do go out in the winter, but I don't want to dig soil in the winter. And like I said, the metals testing I think is really important, and all the tribes kind of fill the gap. A lot of times the state doesn't make it around to all of our water bodies very often, and if they do the very baseline data, and that's it. And so the tribes in our area are kind of the main data collectors for the state of Oklahoma, and all of our data becomes publicly available, and we're proud to be able to share that and do the work that we do. Alrighty, I think that's it. You have any questions or anything? No?
Thank you, Debbie. I bet if anybody have it, she'd know. She's a water woman. Thank you, Deb. I'd like to shift gears. We've been talking about water, but where does water go? And what do we need? What else do we need? We need soil. And I'd like to introduce you to Gretchen, who I never want to say your last name wrong, from Kansas State University, and I'm not going to do it. Thank you very much.
Thank you so much. And first of all, I cannot say enough. Thank Rebecca enough for getting me here. I've always wanted to go to this conference, and there's always something in the way. Well, when she put me on the docket, I have to show up. So I am so glad I came. This has been a wonderful conference. Do I have to do something to start my slides? Okay. Yeah, I'm Gretchen with the long last name. I'm a cropping systems agronomist from Kansas State University, not in Manhattan. I'm at the Southeast Research and Extension Center in Parsons, so I'm right across the border. It was great seeing, I'm so glad that Debbie put the map up because I forgot to put big maps up. Yes, Kansas donates a lot of our topsoil to Oklahoma. A lot of our topsoil. And I always I work with farmers. I'm a professor, and I've got 80% research, 20% extension. And I work with farmers, and I always tell them, I know folks in Oklahoma. There's some really nice folks down there, but we need to keep our topsoil in Kansas. And that's a lot of what I'm going to be talking about today is the interaction between soils and everything we've been talking today about water, and how critical that is to really understand the science behind that and the interaction between those. And soil versus the that should be it. Oh, that's the PDF. You can put the PDF if you want, unless you can find the other one. Okay. So if he gets the PowerPoint, it's better because it's got action in it. It does things, and so if you can. Nope, wrong one. I can do this again. No, I can't. But, there you go. There you go. The Soil for Society. There you go.
Give me a second, I got
Yeah, yeah, okay. There we go. Okay. Okay, now, how do I advance? Do I do the up and down? Okay.
There you go.
Okay, good deal. Thank you. Also, if anybody has any questions while I'm talking, just, I can't see you because of these lights, but just, shout and let me know, and I'll stop. And that's my contact information. You are welcome to contact me before, during, or after. Anyway, what I want to talk to you today is about soils. And we kind of all know everything there is to know about soils, right? Well, soils have sort of three major characteristics: the physical, the chemical, and the biological. This is actually an electron scanning micrograph picture of a Canoma silt loam soil from Parsons area. Soil's really cool stuff. We tend to know a lot about the physical characteristics of soil. The biggest reason is because it's easy. We can take a picture of it. It's very static. It tends to be very consistent from one measurement to the next. But the mineral composition, the physical characteristics of soil, we tend to know a lot about. And we generate this map, which is the U.S. soil textural triangle of percent sand, silt, and clay. We have a lot of clay in, do we have a pointer, or do I have to do this? There we go. Okay. So we tend to think of topsoil as the good stuff. This is a field of a farmer that I was working in, and you see we've got 0 to 3 inches and 3 to 6 inch. So as we're going down in depth, we look at the change in soil characteristics. Oops, I did the wrong thing. There. And we see, I'm not going to do this because I'm going to change it again. The black dots are 0 to 3 inches. We have a clay pan in our area. It includes some of this area too, which means there's abrupt textural change. We go from a really good productive silt loam to a very heavy silt clay. You can see the black dots go all the way into the silty clay, and there's a red dot at 3 to 6 inches in the clay pan. That means this guy has 0 to 3 inches in that area of the field that's good silt loam, and he hits clay pan. That is from agricultural activity that has eroded the topsoil, the top 12 to 18 inches of topsoil, and it's all down here in Grand Lake. He's lost his topsoil, okay? The chemical composition of soils are also something that we study a lot about. Again, they're fairly easy to measure. We take a soil sample and we look at the pH and the nutrients in the water. So the soil chemistry, critical things that we look at are nutrient cycling and water cycling. Nutrient cycling is very important for crop productivity, and we tend to add a lot of external nutrients to boost our productivity, our yield. In the past, they didn't have to add as much because the soils were naturally more nutrient rich. But the nutrient cycling and the whole cycling is a very important process. Soils store nutrients and water. They then make that available to the plant. We have gotten into a mode where we think we have to add everything to make it available to the plants, when in fact, if we have healthy soils, these nutrient and water cycles will naturally occur and support plant production. Water cycling is critical for everything that we've talked about today. To keep water clean, we need to have healthy soils, and that's something I'm going to keep saying because that is the most critical thing about soils. This is the profile of clay in our area. Like I say, we tend to have a lot. We have a clay pan. You see the clay content goes from about 20% up to 50% right at about 12 to 14 inches. So we have this very dense clay layer. The soil above it is more erodible than that clay layer, but the clay really changes what is available. These are a series of measurements from my graduate student, Jerry Shao, looking at changes in the vertical distribution in different soil types. So we have the conventional till, which is the solid black dot, a no-till situation, which is the open triangles, and then the closed circles, the light gray, is a hay meadow. Now, by a hay meadow, I mean something that is growing grass. This part of the country was formerly tall grass prairie. That's what our soils are good at growing. That's what they like to grow. You'll notice as you go down, first of all, there's huge differences between the no-till and the tilled, and then an even bigger step to the hay meadow. You'll also notice the vertical distribution changes as you get into the clay pan. So the clay layer has a lot of dynamics going on that change that vertical soil profile. This is looking at beta-glucosidase, which utilizes carbon. It takes carbon up and breaks out and makes it available to plants. The acid phosphatase is used to access phosphorus. Again, we notice a big difference between the tilled and no-till, and an even bigger difference with the hay meadow. Again, a shift in the clay layer. N-acetylglucosamine is used to access nitrogen. You can't just pour a bottle of whatever nutrient you want in the soil. The plant has to be able to access that nutrient, and these enzymes are what drives that activation. Again, the hay meadow has a much higher activity in the clay pan of N-acetylglucosamine to access the nitrogen. And again, we see the shift through the whole growing season, the difference depending on what crop we're growing, huge difference between no-till and conventional till. Now, looking at the water cycle, this is water use by a corn plant. And this is a Canoma loam in Parsons, or outside of Parsons, actually it's Bartlett, so it's even closer to here. You see by the middle of the growing season, about June, that plant is taking up almost ½ an inch of water every day just for its typical growth. If we have a difference between a tilled system and a no-till system, we have a lot more water stored in that soil in the no-till system. The conventional tillage has only 8% water. The 5-year no-till has more than that, and the 10-year no-till, actually it's even longer than 10 years, has double the amount of water available for the plant. No-till is not going to solve all the flooding issues, but it's going to have a huge difference. If we can hold more water on the soil, we have better water cycling in the soil. We don't have the erosion problems. We don't have the flooding problems because we're holding the water on the field rather than sending it to our downstream neighbors. You can see here the corn basically runs out of water and turns into a deficit about the middle of the season. Big difference is for every 1% increase in organic matter increases the soil available water more than 20,000 gallons per acre. Huge difference by reducing tilling, leaving the corn crop residue on the field, and going to a cover crop type system that really increases the organic matter in the field. The soil chemistry is really critical for nutrient and water cycling that directly impact water quality. We need about 4,000 gallons of water to grow 1 bushel of corn, or about 1.2 acre feet of water each year. If we keep that on the field rather than sending it downstream, we're in better shape. Another really critical issue, change, when the plant is able to cool because of water, it makes a big difference on temperature. This is an interesting figure. I've got you see the canopy temperature of the crop canopy, and that's the open circles at the bottom. The air temperature, it's at about 82.5. The air temperature is about 87.5. That plant canopy is well watered. It's able to cool. This is a bright sunny day. The yellow triangles show full sunlight, about 1,800 micromoles of radiation. This is a well-watered plant. Cool. It can cool itself. A drought-stressed plant is much hotter, directly related to soil, plant available water in the soil. How much can it cool? Sounds like a complete non sequitur. This is directly related to eco-justice, environmental justice. Because hot environments, first of all, they're going to get worse. Secondly, poor people live in hot environments, directly related to soil quality. So we've got the physical, the chemical. Let's talk about the biological. The biological is something that we're really just getting into measuring. We don't understand it a lot. It's also extremely dynamic. So depending on what day of the week you take the measurement, whether we just had rain or didn't have rain for a while, or whether what we've planted, it's going to change. It's going to change drastically. But the plant biological, or the biological components of the soil include plants, bacteria, fungi, nematodes, arthropods, earthworms, and even animals. I've got a whole bunch of organisms that live in the soil. And as a matter of fact, the components of 1 teaspoon of soil are more than 1 million to a billion. More critters in 1 teaspoon of soil than on Earth. Very difficult to measure, difficult to get a handle on what they're doing and how they're changing, but it really lets us see soil as a living, dynamic environment, not just a static sand, silt, clay. We've got the soil bacteria, such as the nitrogen-fixing bacteria, the nitrifying bacteria, the denitrifying bacteria, and then the actinomycetes. The actinomycetes in particular are important in forming the soil linkages with plants that transfer nutrients to the plants. The fungi are another really fun group of folks. Saprophytic, mycorrhizal, pathogenic. There's a lot of pathogenic fungi in the soil. A lot of what I'm looking at in my research is looking at how the soil health interacts with the fungal load, especially the pathogens, and then the parasitic fungi as well. There's also finding all kinds of new things in the soil, such as antimicrobials and so on, that are helping us a lot. There's a concept of suppressive soils that contain microbial communities that naturally suppress disease-causing organisms. This is actually a second scanning electron microscope of a fungal hyphae in the Canoma silt loam. Some really cool stuff, and this is a lot of what I'm doing research on, is how to control disease-causing organisms by looking at soil health. Again, looking at Jerry's work, change with depth. We see a big difference between tilled and no-till. Most of the activity happens in the top 6 inches. A huge break when we get to the hay meadow. And you could see it's a 10-fold increase between the tilled and the hay meadow. So we have a huge potential for microbial activity in the hay meadow. Again, big difference between tilled and no-till. So why is this important? It's difficult to change the physical composition of soil. We're pretty much given what we have as far as percent sand, silt, clay. We can influence the chemistry of the soil, especially the nutrient and water content. Frustratingly, a lot of our current pollution and problems has come from the Haber-Bosch process that's putting on external nutrient values. We're learning a lot about the biology to improve the soil nutrient status naturally with regenerative ag and reduce the amount of external chemicals we're dumping on it. The critical thing we need to do is improve the biology of the soil for nutrient and water recycling, for better managing the whole process. Soil is defined, or soil health is defined as the capacity of the soil to support life, support a vital living ecosystem for plants, animals, and humans. We've got soil health as the productive capacity of that soil. And some of the functions of a healthy soil: sustain life, it provides us food, it provides a habitat for us to live and work, the nutrient cycling, filtering and buffering. And this is huge, especially, I'm sure Grand Lake is having this problem. When we erode sediments and nutrients from a field, they fill up reservoirs such as Grand Lake. That reduces the capacity of Grand Lake to hold water and manage floods. I haven't heard anything about Grand Lake, but I'm sure it's happening. We're having a huge problem in Kansas at the John Redmond Dam. They're doing a billions of dollar project over the next 20, 25 years to dredge John Redmond. It's extremely expensive. If we would just keep the soil on the field, we wouldn't have to dredge the reservoir. When you silt in the reservoir, you lose the buffer and you lose the capacity. The amount of water you can store in that reservoir decreases. You don't have the depth you want, and it causes all kinds of problems also with sediment and nutrient, with harmful algal blooms that are toxic, dreadful. So healthy soils directly relate to water quality, water availability. One of the things someone mentioned about those who fail to study the past are doomed to repeat it. When the explorers came and started going through this area, they would write about the pristine conditions of streams and creeks. Can you imagine seeing the stream bed of any stream or river in this area? That was normal. Now this muddy gunk that we're so used to, that's what we think a stream is. That's not normal. That is not normal. We should be able to see the bottom of that stream. Can you imagine that? Wouldn't that be beautiful? That's what we need to work for. And that needs to stop all of the sediment and nutrient losses. Principles of soil health: keep it covered, minimize soil disturbance, increase diversity, continual living root, and integrate livestock. Now I'd like to go a step even further and go beyond just the natural sciences of the system and posit that soil is critical for society. We've got the natural environment. I've talked a lot about that. Water and nutrient cycling. Air quality, I didn't touch on that, but it's critical for that as well. Carbon management. Humanity. We need to be able to support people, but also society. Development of society is dependent on soil. The natural environment, like I said, water. Very obvious how critical healthy soils are for healthy water. Air. This past year in Illinois, there was a major, I forget how many people died because of a dust storm that closed a major roadway because of sediment loss, dust soil blowing, and it caused, multiple car pileup and multiple deaths because of a dust storm. Can you imagine having a dust storm? When has that happened? in the past. Biodiversity, critical for our future is biodiversity. We have organisms in the soil that we don't even know about yet that produce pharmaceuticals that we need. We don't even know about them yet. And carbon management. Carbon, the global climate change that is critical, soils manage carbon. Humanity, what do we need to support human life? Food. We need food security. We do not have a food system that works. We are failing in our food production. We have food deserts in one of the richest countries in the world. We have food deserts. We have people that cannot access healthy food. Farmers are killing themselves because of the food system. In extension, we have a whole program talking about depression and suicide in farmers. Ouch. Land resources, fascinating subject. Really want to get it. We could do a whole thing just on land resources. The difference in definition between land and soil, we tend to use them interchangeably. Soil we think of as having the three properties that I was talking about before, as a dynamic ecosystem, that kind of thing. Land we think of as a possession, okay? A possession we can abuse because I own it. And that attitude has come from, it's now been labeled the Anthropocene, humanity's effect on the world. I was reading an article, they call it the plantation scene. I'm not quite sure how to pronounce that. But it's all about our mentality coming from a plantation mentality of ownership. Okay? Another ouch. We're not thinking of our system. We're not taking care of our system. We're not stewards. Energy. Yes, we need energy to live. Pretty much all energy on Earth is harvesting sunlight in some fashion or another. There's lots of options for generating energy. And then climate security. Again, climate security is real critical, not just for carbon management, but as I showed in the temperature extremes are going to get worse. Society. What do we need to move beyond just living and create a society? We need health. Again, healthy food, nutritious food. Economy. We need economic stability, economic development. Environmental justice. Environmental justice. Oh my gosh, this is so critical, and it's going to get so worse. I loved the presentation on environmental justice. It was awesome. I actually grew up in a Superfund site that I did not know about. You might have heard of the Manhattan Project. They developed all of that in the St. Louis area. That's where I grew up. They just, in the past 5 years, closed an elementary school because of contamination of the playground. The Corps of Engineers came back in and remeasured it. Oh my gosh, it all went away. There's no more contamination. Can you imagine that? So anyway, they have been flogging around. When was the bomb dropped? 75 years ago? They've been flogging around for that long not doing anything. So yeah, it's environmental justice, and it's going to get much, much worse. Temperature, water, pollution. EPA has a map. If you want to go look at it, I always forget the URL. It shows the environmental injustice, and poor people live in poor environments, directly related to soil health, taking care of the soil, maintaining it, growing good plants, everything. And then social, and the social structure. So we have an organization called Soil for Society. It's a group of researchers. You can join us there, Soil for Society. It's funded by NSF. We are looking at developing a network of networks to address some of these issues. We've got a whole bunch of people here, the ExcelNet. We've got a whole bunch of partners, and our vision is to create resilient food systems. We're focusing on food, but it's all about land and soil management. And how can we transform land and soil management from the problem to the solution. We are in the process of co-designing the network. We would like to invite you to join us in that. And that's my presentation. So thank you all very much. If you have any questions, please contact me. Oh, there we go. Please contact me. I've also made this available. If you want any slides, you're welcome to them. Thank you all very much. And again, thank Rebecca for inviting me. Sure.
So thank you so much. But it does seem like the research that was done would be more complete comparing organic.
Oh my, yes.
Okay.
Oh, yeah, we don't have
So
organic.
just to capture what no-till,
Yeah.
according to Monsanto and regenerative agriculture, includes dumping tons of chemicals on.
Yes. That's the problem is the definition.
Yeah.
Because it's what do you want it to be? Because if you want regenerative ag, it totally depends. The other thing too is like, we are so stuck. And I'm sorry, I do corn, soybeans, and wheat. That's what I do. That's very frustrating. I'm planning on retiring, but I was one. People don't eat those.
Thank you. Yeah. So
No.
it's
we
for
don't-
livestock,
that's
it's
not what we
for
need.
cars.
Right. That's not what we need. We need apple. I mean, somebody did a study a few years ago that if there was, I think it was when the trucks were not running. And if trucks can't deliver stuff, we all starve. And they were showing how people in Iowa would starve. Iowa used to be the biggest producer of apples. They don't have apples now. Yeah, the other thing too, it's little things matter. Put a native area in your backyard. Don't mow the stupid thing. Put a meadow in it. Do little things to keep it, to change our thought process. I really want to pursue this concept of the plantation mentality because part of it is it's so ingrained. It's like seeing a muddy street. That's just what it is. What can I do about it? The plantation mentality, when I was reading this article, I was like, I never thought, but it's so ingrained, the manifest destiny. Who came up with that? And these folks will say, it's biblically defined that man is over top of. That's not the Bible I read. It says I'm supposed to be a steward of what I was given.
And the Pope took it back, I think, 15 months ago.
Yeah, not that I'm supposed to domineer it and conquer it, but I always think, what is it? Ellie Bob, can all the conquering be around? Right, it's in Ellie, what's his name? It's the kids show. Oh, Aladdin.
You're awesome. Thank you. Yeah, sorry.
Well, if you have water, if you have soil, then you might want to have parks. And you might want to have butterflies. And you might want to invite up the parks manager for the city of Miami to come and talk to us about the pollinators here. Thank you. I'm afraid I'll mispronounce your name again. Zeb Migari.
Thank you. Thanks for having me up. As Rebecca said, I'm the parks manager here in the city of Miami. And part of what we have here is we have 13 different parks in this town. And we have... Microphone, sorry. Oh, yeah. So I'm pretty loud, so I ought to be able to get there. So we have 13 parks, and we have a number of those parks that's currently setting in flood zones. So it's kind of limited on what we can and can't do with those parks. So one program that we've gotten into is we've created what we call pollination stations. And that is, we've we've developed the ground and we've planted native species of flowers, grasses, things like that to, for one, stabilize the soil, and for the other is to make them minimum maintenance, but to also bring some beauty into our parks. So we have that currently at Torbert Park, and we have one over at the M Street Walking Park, which is just directly on the banks of Tar Creek. All that together, we have about 11 acres total in pollination stations currently. They're doing well. We mow them about once a year. Otherwise, we just let them go and do their thing. Another program that we're actually looking at, and I've just recently had some conversations about our park there at the south end of town, Riverview Park. There's approximately 34 to 35 acres of land there that we're unable to do a lot with. We just maintain it. So what we're actually looking at is planting pecan trees. Rebecca here is very passionate about those. Like I said, we have about 34 to 35 acres of property there that we're looking to partner with a local business that is going to help us do like a grid or a pattern to lay those trees out. And if everything works right and we are able to do what we need to do with the layout, we're looking at almost 900 trees. There's currently a lot of pecan trees down there. A lot of the public goes in and out, harvest those so they don't go to waste. But I mean, and part of that'll do is, you talk about the erosion control and things like that and getting soil into the Neosho River because it runs smack through the middle of it. Is that will also help with the erosion of the banks and everything that's there. So if everything goes well, maybe next spring we'll start to see about a whole lot of 4 to 6 foot tall pecan trees in that area. So, so that's about all I've got. Any questions?
I've got questions.
Sure.
Thinking about your 11 acres of grasses and native flowers and stuff, assuming and hoping that continues to expand into other areas
Sure.
that are suitable, just a thought, what if you partnered with some college students to harvest seeds and
Sure.
partner with the city library to have a seed library of native seeds and plants that people can plant in their yards?
That's fantastic, Mark. It really is. And it's something, like I said, these programs are really been into it for about 2 years now. I'm very new to this city. I'm not from Miami, so I'm actually from Kansas. So I figured I'd come back and take some of my dirt, But yeah, I mean, we're willing to, as far as the city goes, our attitude is to work with anybody and everybody that we can.
You're going to line up.
I hope so. Yes, sir.
How do you establish one of the pollination stations? You use like Q4D or Roundup and just scorch earth it and start over?
Kind of what we did is, and I'm not 100% sure how this was, because this all was established before I started here in the city. The way I understood it is they pretty much took it down to just bare dirt. We worked the ground just like you would any other farm plot, and then everything was seeded in. And then basically you just walk away from it and allow everything to establish. And part of that program with pollinators are, you don't touch it for a minimum of a year to 18 months. You do nothing to it. And then when we do go back in and mow it and do any kind of maintenance on it, it is mowed at a very high level. That way you don't actually get down into the roots and disturb anything underneath it. So you mow it probably 12 inches tall. You're just knocking the tops. That way the seeds get back into the top and they go right back into the ground.
Did you say you're going to establish a pecan?
We're looking to. We haven't yet. We're in talks, and I've spoke with a nursery and I've spoke with a local business down here at Miller Pecans about helping us set up a layout and a pattern for getting those trees put in. Nothing's been done at the moment. It's just in the very early planning stages of this. So.
Do you mind telling me what nursery?
It's Baker Nursery. They're actually in Tishomingo. And it would be something we would get with them, and it would be, part of that is the tree and planting of the tree.
Have you been?
I have not.
there was, the reason I asked that is I arranged to buy pecan trees from, and I don't remember if the name was Baker, but it was a pecan orchard near Tishomingo. Drove down there, took a trailer down to be able to bring back, couldn't find it.
Really?
Yeah.
I spoke with a gentleman on the phone I was actually put in contact with from Miller Seeds. I've got all his contact information if you'd like it.
I would.
Perfect.
One last thought. When you get, assuming that it gets to the point where you're ready to actually do this project,
Sure.
I'd really love it if you try to engage the community in some way in that
Sure.
process. I mean, the historic connection to Riverview Park is going to be a fundamental change to the nature of the space.
Sure.
And it would be a great way to build community awareness and engagement and knowledge of what's coming next.
Absolutely. And, you know, as we get closer and we keep moving forward with this project, it'll be something that I'll keep in contact with Rook and yourself about. And maybe we can partner with something like that to get people involved. For sure.
Yeah, thank you.
All right. Thank you so much for having me.
Well, that is some exciting news. I'm really thrilled to hear about that. What? Oh, okay. All right. So next up, we have perhaps our second most distant visitor, since this has turned into a traveling contest. Maybe the third, yes. So next up, we have Dan Braybaker, and Dan has a remarkable history here. Do you have slides, Dan?
Yeah.
Okay, Mike, do you have those? Can you be working on that while we do the introduction here? That'd be awesome. Thanks. So Harvard University came with a team of researchers 20 years ago, and Dan was one of those researchers. And in the last several years, he has been working with us, and his students have been working with us. This is actually the second year in a row that they have come to Tar Creek to do field work, to collect sediment cores, chat pile samples, surface soil samples. And what they collected last year kept them busy in the lab for an entire year. And now they have another set of samples that hopefully will keep them busy for another whole year. And Dan is here to share some of their results looking at chat wetlands research. So Dan, come on up. Yeah. You found the trick. Yeah, plug it back in. It's good puzzle this morning.
Hey everyone, it's great to be here, and I want to also say that we're going to share the podium today with Claire Hayhow, who has been thinking about Tar Creek for quite a long time, and did and did an honors thesis with working on Tar Creek during COVID times when we couldn't travel, and Rebecca sent us lots of samples we did science by mail, which was spectacular. It is a great honor to be here and to share some of our research with you all. And we're trying to try to convey some important points about how metals are moving in the watershed. It's great, everyone has a real good concept now of what the watershed is and why we have to figure out what's going on in the top of the watershed and how that impacts folks further downstream. So let's go ahead and start here. I want to just give you one new word to think about, and that is geomobility. And if you could take that idea away from this presentation, that would be probably one of our highest goals here. And that's this idea that metals or whatever is in the chat pile or whatever it is of material of interest that can be readily mobilized by natural processes. So we're not including all of the anthropogenic or human processes. And all throughout the day, we've heard about some of these things already. So we just heard about runoff and soils and how this is affecting the biogeochemistry of rivers, wind, and the solubility of material in water. All of these things can affect how far things transport. And collectively, we call that geomobility. The question then is, why should we care about this? And it makes sense, right, that things that can move around in the environment that may be bad have a greater risk of having an impact for both environmental and public health consequences. So we can characterize some material like chat, and we really want to focus our attention not just on the bulk chat, but on the components of that are most likely to move within the environment and perhaps have deleterious effects for either the environment or folks. So the other thing that we're going to take away from this presentation is sometimes you have to not look at the bulk characteristics, but you have to put the microscope on the parts of the system that are most likely to be an issue. And so let me just quickly clarify. We can see the wind transporting off of a chat pile. We can see the fines there. The fines are being blown over into an agricultural field. And then you can see us on Tar Creek taking some sediment cores, trying to see how much material has moved down Tar Creek. Okay, maybe we can go ahead next one. So we're going to make a quick presentation of two different agendas here. One is to try to understand what's going on with the chat piles as they are undergoing reprocessing. I think many folks in the community are aware that almost every chat pile, historic chat pile, has been undergoing some sort of reprocessing. And the question is, during this time of reprocessing, what is the material like that is now on the surface that used to be buried deep beneath the top of the chat pile? And then the second part we're going to be interested in is wondering about what is being transported, the runoff that comes off these chat piles versus the runoff that is coming from the mine drainage and ending up on our floodplains. And can we fingerprint that? Is there a way to be smart about saying, hey, when we see this in a floodplain soil, can we attribute that material to either coming from a chat pile runoff or from the mine drainage itself? Okay, so I'm going to talk a little bit about the chat story and then pass it over to Claire to talk about the floodplain soils. So there's a couple of questions here that were on the table. Has the geochemistry, has the material at the surface of the chat pile changed as a result to this reprocessing and removal? And then the second is, can we develop a fingerprint that will help us better understand future risks? So I'm going to give you a couple of maps. We're also map geeks. I think anybody who works with it, who's a map geek? It's like probably a good fraction of us can be guilty of that. We love this watershed map that you all have now. It's so spectacular. One of the things was probably the theme of last conference was just look at how many chat piles are on the floodplain, right? And so then we went from that image to the one where we have a little star on there. That's the chat pile that we had worked on. And you can see we picked an area that showed recent reprocessing. So you can see where they've been reprocessing the surface. And then yesterday, thanks to the toxic tour, we got onto this pile and took a sunset photo just so you could see the waves on the surface of the chat pile for where they had been harvesting that. And then finally, the arrow is showing you a cross-section that's about 1.5 meters, where you go from the top of the chat pile down, and you can see that there are very distinct layers. And we started to ask ourselves, if we were to look at these layers individually, how different are they? And that was the question that we put on the table. So there's a lot here, but the question is, how has this changed while the piles have been reprocessed and removed? From left to right, yeah, we can see the surface, the soil, and the mine drainage. And then we can see 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 the mine drainage. And then we to the subsurface to further down in that little cross section. Remember, the surface to the basal is about 1.5 meters. So the scale of this is like something like that. And then we see lead, zinc, and cadmium, right? Those are the heavy metals most associated with the mining activities, and manganese and iron. And what we can see on the bottom of the axis is grain size. And the finer grain sizes we have seen, as others have seen as well, have higher concentrations of metals, quite dramatically so, right, in some cases. If you look at lead, right, you're seeing concentrations in the fines approaching 12,000 parts per million in those surface samples. That's quite a little bit different story than what we had when we sampled before the reprocessing had begun. That's us. So what changes do we see as a function of the mass of the different grain sizes as we move down the pile? And the top one, we see the archive sample from 2005 when we were here as part of the Harvard team. And then you see those 4 samples again, sampled last summer. And the heterogeneity is spectacular. So there's a wide range now of fines in terms of grain size that we would not necessarily have predicted if we were just sampling along the top of the pile and trying to get an idea of what is the pile like. Now we're seeing that the pile has a lot of heterogeneity, and from the perspective of geomobility, those fines are the ones that we care about because they're the ones that can blow off the pile, or perhaps they contain minerals that are new, that are holding the grains together, that may be more soluble, and then can be transported by water when some of these piles are in the floodplain. So those are some of the big questions that we're asking ourselves. And then we can ask ourselves how much lead is in each layer and in what size. And again, the takeaway from this graph is there's so much variability on a very small scale. So then how do you develop a risk assessment when you have variations that are a factor of 3 difference in terms of total lead concentration? I'll note out that the bottom graph there is milligrams of lead per kilogram of chat. So that one sample has 1,500 milligrams of lead per kilogram of chat in terms of trying to wrap your head around what that might mean in terms of amount. And we see that most of it, right, is associated with those fine materials, which we know are the most geomobile. So the act of putting this under the microscope and determining not just how much lead is there, but where is the lead and in what size fraction really changes our perspective about possible risk and mobility of lead within the chat pile. Okay, so here's my last slide. I'm going to pass it over to Claire. So what are some key takeaways that I want you to think about? The new layers of chat piles that are exposed from the surface, that we're observing way more heterogeneity than we were when we were walking on the piles 20 years ago, sampling on the surface. And that is important in terms of understanding or characterizing what is this material like. And so we have a whole bunch of new questions that we're still working on, and probably, Martin, maybe this is 2 years worth of samples we've collected. Maybe we will see you in a couple of years. That's that much work. But these newly exposed surfaces, are there new minerals there? I think the answer is yes. And then our question is, what is the risks associated with these new minerals that were safely buried before, but are now near the surface? And then characterizing the geomobility of the metals in these newly exposed surfaces really needs to be a priority task as we evaluate risk. And that's going to be something we're going to work on for everybody here. We're going to try to figure that out. So I'm going to pass it off to Claire. And yeah, we could ask some questions here. This is a good point to take a moment, sort of think about what you just heard, and ask questions if anyone has a question. The question is, when we say new minerals, what do we actually mean by that? Right, and so when we are now on the surface having material that was buried for 50, 60 years, having that water percolate through it, that water carries ions in it as it's going through and dissolving the chat, and then precipitates new minerals in place. And in fact, those new minerals seem to be cementing the grains together. And so this new chat material is quite hard. You can put a spade into it and not get any material to come out. And then one has to ask yourself, how easy is it to dissolve that sediment now that it is exposed to the surface, or exposed to flood when the Tar Creek floods these chat piles?
Another question, which I know you won't have an answer to, but I know. But it makes me wonder if you had actual new minerals in these lower layers, right? And you have this material, some of it being sold for use in road aggregate in a mixture, right? How do those new minerals affect the safety of that aggregate as the road eventually degrades? That is, might there be a difference in the safety, the long-term safety of this road material with the chat they're using now versus the chat that they had access to when they first began selling it?
Well, Martin, you're right. I don't have an answer for that. But it's something we could for sure work on. And it also sort of depends on how the process of harvesting and reprocessing happens. And so I think that's an opportunity where I think when our conversation about soils, right, we really need to think about this from a systems perspective and take what we learn and apply that to the folks who are doing the work and say, if you just did this, then you wouldn't have that problem, right, in terms of the way in which you process the material. So I think that really calls for the kind of things that LEED does so well, is bringing people whose worlds don't ever collide and say, I've learned this thing, try this, it'll make things better for you and also downstream. So I think that's the way I would approach that. Yeah.
What would be like options for applications after your findings are complete? And like how could this change the way the shop piles are managed or processed and stuff like that?
Yeah, so the question is, after we figure this out, what kinds of changes might happen in terms of how this material is processed? And I think that's analogous to Martin's question in some degree. I think we need to know more information about the new mineral phases that are present to sort of make some recommendations about what that might be. I think there's an opportunity to perhaps be creative there. And I'm not sure what that looks like now, because we don't have enough information yet. But we're certainly thinking about that, for sure.
Have you shared these findings with the EPA? Alluding to really good effects of remediation strategies. That's what they're doing right now. They've offered the opportunity to pause what they're doing. Effectively, a lot of implications for the overall remediation strategy.
Yes, that's a good question. The question is, how much have we shared this preliminary work with the EPA? One of the things we do is important for me and my undergraduates is to present at conferences. And so we have presented our work at national conferences. And through those presentations, we're actually collaborating now with folks at U.S. Geological Survey and EPA to try to understand some of these questions. That process has started. It's going to be a while before we take the information that we've learned and promulgate that into changes in operating procedure. But you're right, we definitely need, it's another example, right? We need the academics and the EPA and the interior people all to be working together and it's surprisingly challenging. And you know, it actually, the one who makes this happen is the ringmaster who's sitting right here, and has orchestrated a whole range of folks with different backgrounds to tackle these kinds of questions. Yeah. All right. I think I'll pass this over to Claire. There's one more question. Yeah. Is the chat contaminated? Is that a question? Yeah.
Does that mean the chat is a hazardous material?
So there are. Is there a person from EPA here? Okay, yeah. You want to answer that?
Jim, can you answer that?
Yeah, I'm sorry, I didn't hear the question. So, Jim, the question was, is the chat a hazardous material based on this? That's the question.
Even without this, it's a hazardous material, so I don't.
Right. Thank you for.
Thank you. Yes.
I think it's important that we all agree on that point.
Thank you.
Yes, it is. The answer is yes. It is a hazardous material.
It's not a hazardous substance.
Yes.
No, it's not a hazardous substance. Materials within it are hazardous substances.
Okay. Important clarification. Thank you. Yes.
And Claire, thank you, Dan.
Okay, so we spent a little bit of time talking about kind of what's going upstream, and so then what we also then wanted to do is look at whether or not we can use the two main metal sources, which we looked at Dow Bridge, to identify this tracer for both mine drainage and chat runoff. And so when I say tracer, essentially what I mean is a kind of distinct feature or kind of fingerprint for each different source that we can then use throughout the watershed to try to figure out where it's coming from. And so then what we then wanted to do is use this tracer to identify the contributions of metals from both mine drainage and chat runoff on the floodplain and throughout the watershed. And so when we did this, we took two cores. I'm going to show you pictures. We've heard a lot about sediment cores or soil cores, so I'm going to show you some pictures so maybe we have a little bit more context. And so these are the two sampling locations. So this white star is the one that we took for the chat runoff, and this red star is for the mine drainage. This is at Dow Bridge. And so then again, we're really big fans of this map, so I used it again just to kind of contextualize where we are. And so then we also then looked at some floodplain soils, and then we also took a core in the floodplain. So all of the floodplain soils were taken with Harvard, and so that's all of these images on the right here, and then we also took a core, which you can see with this red dot over here. Okay, so here is our sediment cores, and so on the left we have one from the mine drainage, and then on the right we have one from close to a chat pile. And so you can see essentially what we do is we take this big tube, we put it in the ground, and then we're able to capture essentially what is in that section of the ground, take it up and look at it. And so when we're looking at this mine drainage one, right, you have those very clear, red, very iron-rich sediments. And then what we think we're seeing is actually the beginnings of chat, which were there before the well started to overflow. And so we're looking at elements here, so we're looking at carbon, silica, and iron. So those are kind of the big key players here. So this is a measure of concentration and depth. So we see concentration on the x-axis, and so that goes up to 30%, and then this depth. So these are both relatively deep cores, so this is going 30 centimeters down into the sediments. And so we see this inverse relationship where we have either really high iron or really high silica, and then we see carbon kind of change as we see roots growing or maybe not growing. And so then when we're looking at the chat pile, we see these maybe less clear relationships where it's kind of just constant throughout the core, which I think is indicative of it being more constant over time, right? Because one of the really cool things that we can do when we look at sediment or soil cores is that we're able to go back in time, because as we move down, we're going back in time. And so then what we really wanted to do is be able to identify this tracer or fingerprint for lead sources using these cores. So before we were looking at kind of the most major elements that we find in soil or sediment, and now we're looking at lead. And so we can see this, it's not super clear on this projector, but so this, okay, if you see my mouse, this line here is the mine drainage, and this line here is the chat runoff. So we can see that for the mine drainage, at the surface, actually, we weren't even able to detect lead with our instruments. But then once we start going back in time, we can see that it increases to a point where we're getting to 2,500 parts per million. And then for the chat runoff, we see it consistently around 1,000. And so what we then wanted to do is find this fingerprint for each of them that we can then use throughout the watershed. And so what we were able to do for the mine drainage is we found a really solid relationship with the mine drainage and uranium. And then for the chat runoff, we found a really consistent relationship with gallium. So these are two elements that we were able to use to then say, okay, there's a really solid relationship with each of these two different sites that are the main sources of these metals. Okay, can we now use them to look at how lead is moving around in the environment further downstream? I also just want to say that we were able to look at kind of who is there. So I think that this kind of is getting at the mineralogy question that someone asked earlier. So if concentration is a measure of how much is there, we were able to look at mineralogy and speciation, which is kind of the who is there. And so we were able to see that things like sericite and lead phosphate, these are all things that we're seeing, and these have different geomobilities, and they also are differentially taken up in the body, right? So we know that galena is harder for our body to put into our bloodstream than something like sericite. And so then how are we thinking that this is getting from Douthit Bridge to the floodplain? We think that it's right these HFOs, which we can see in the water. And so when we're then looking at metal concentrations closer to the floodplain, these are again two of those sediment cores where we see that at the surface there is less lead and less iron. And so what we then wanted to do is compare this with these tracers or fingerprints that we found to see, okay, we have these high levels of lead lower in the core, but where is that actually coming from? So what we did is we created a model where we can see that mine drainage is down here and chat runoff is up here, and we can see that there's actually a really strong relationship between these two endpoints. So this R squared value is a measure of how strong they're related to each other. So a 1 would be, it's like a 1-to-1 relationship. So we think that this is actually doing a really good job of capturing the metal sources in the system. So we think that this is a really good model actually to trace these two sources throughout the watershed. So then we looked at that with floodplain soils, and we saw that that relationship continued to hold. And so what we're seeing is that mine drainage is consistently associated with higher lead concentrations in the floodplain. So I think that the key takeaways of at least this piece, and again, I'm happy to take questions after this, is that the chat piles being processed and removed affects the geochemistry and has really big implications for metal mobility. I think that this tracer has the potential to really help inform mitigation and thinking about how mine drainage and chat runoff and how they're mixing maybe is affecting folks and the concentrations that they're finding in their yards. And again, like I said, that mine drainage carries the highest concentration of lead into the floodplain. And so we really want to think about potential remediation and what that would mean in terms of, how to get that fixed. So, and again, all of this is relating back to Grand Lake and how that changing of the height would potentially affect contamination and remediation. Yeah. Yeah, does anybody have questions?
Did you say there's uranium in there?
Yes. Right, so I think, yeah. Right. Right, I know. Yeah, so I think, Dan, I don't know if you want to maybe speak to the chemistry of that, but I think that what we're seeing is we think that that's something that's going on in the wells below the surface, and so that has been kind of slower to release, which is why we're only really seeing it in the mine drainage. But I think that those concentrations were also low, but absolutely there. Yeah. Oh.
Do you think, is it migrating into the aquifers, the shallow aquifers?
Mm.
It is in that area?
That's a really good question. We don't have any samples from the aquifer, the more shallow aquifers. I don't know who might. Yeah. Yeah.
You had talked about how one finding was that there are greater concentrations in floodplain soils when you have lead. There are greater concentrations that in floodplain soils, acid mine water has higher concentrations of lead than chat runoff. Am I getting that language exactly right?
Right. So essentially, maybe I didn't do a great job. Oh, repeating the question. Yeah. So the question was, are we finding the highest lead concentrations being associated with mine drainage as opposed to chat runoff? And so that's what this figure is describing, where we have these low concentrations in the cooler colors of lead and these high concentrations in the more warm colors. Did I say that backwards? I think I said that backwards. Okay, so red is high concentrations of lead, purple and blue are low concentrations. And so then it's mapped onto this space that's describing mine drainage at the bottom left and chat runoff at the upper right. So yes, Martin, you got that spot on.
And in this instance, because it's all suspended in a concentration and volume here are essentially equivalent with one another, is that right? In other words, imagine you had a pound of soil and a different pound of soil. You could have different concentrations here, right? And so the actual, but here, volume isn't an issue, am I right? In other words,
I don't know if I understand
your question. Never mind. I'll think about it.
Okay. Yeah.
I think the way you can think about that is that
The amount of water that is coming into the floodplain that is derived from the mine drainage is so much larger in volume, all right? So that the uranium concentration in that water is actually low, but there's so much of it that then we get to see it, if that helps.
Yeah.
Composition of the cores, is it any kind of soil or is it rock? And what biology is going on in that?
That's a really good question. I guess which cores?
Core you have.
Okay, we can walk through them. Yeah, so this is the one, again, that we took up at Douthit Bridge of the mine drainage. And so we do see a lot of roots. Outside of that, I'm not a biologist by any stretch of the
You've got
imagination.
biological activity that is certainly changing what's going on in that.
Absolutely, yeah. And I think that a lot of that is happening at a scale that we can't visually see. So I think that would be a very interesting question, but not one that we've thought a lot about.
Can it be used to remediate this rather than making it worse by digging it up?
Yeah.
I mean, so remember, these are wetlands, right? And so there's emergent macrophytes on both sites. The ecology of both sites is very similar, dominated with sort of cattails. So that piece is similar for both. And we expect that at the present moment in time, these wetlands are sinks. However, if the hydrology changes, does that sink then become a source? And I think if that's one of the things we take away from this talk, that things that at one point in time are nice biological sinks for you, if you're not careful because the system changes and you change the hydrology, can be a leaking source. Yeah.
Right, so I think that can happen both in the physical disturbance of this, but also if we increase water levels, what happens to this wetland? Yeah, for sure.
Such a good question.
Yeah.
For when these things happen. So you mentioned that the deeper in the core it is, the longer ago it was. So have you, I don't know if this is something you've been looking for, or maybe it's a possibility for the future, but is there a correlation between concentrations versus time and when the mines first started overflowing, was there more concentration of lead versus now? And also, is it precise enough to determine when major flood events happen, how that affects the soil composition in those moments rather than just runoff?
Yeah, for sure. That's a really awesome question. So I think the question was, can we use these to try to figure out maybe when things were starting to be released and and can we track flood events? Is that kind of your question? Yeah, so I think that is something that we would definitely love to do. I think that we actually yesterday kind of got the second part of this core, this mine drainage core, so that we have another 50 centimeters so that we can go back another, I don't even know how many years. But I think that we definitely want to be doing some dating on these cores. And then I think also, right, I didn't speak to this as much, but we can see these really clear bands. I don't know if you can see it from back there, but we can see really clear bands in these cores that are downstream that we do think are markers of more significant flood events. So I think that we also want to try to get more precise dates for those as well. Yeah. Yeah, so it's a Russian coring device. I don't know if that means much to you, but you can actually kind of see what...
Handheld, you're doing it by hand?
Yeah, so you...
I have a Giddings. You want to go to 3P? No.
All right, I guess we're going to talk after this. Yeah, so this is only 50 centimeters, but we can do it multiple times.
Thank you.
Yeah.
But I do it in English, imperial units. I don't do metric.
Awesome. Yeah, thank you so much.
Thanks for all the questions and conversation. It's really accomplished.
Yeah, thank you both. All right. Well, up next, we are sticking with similar terrain, I suppose you could say. We have a student from the University of Oklahoma who is studying under Bob Nairn who has done so much with passive water treatment as a remedial tool in this area. And I would like to welcome up Leif Olson, who is going to talk with us about bacteria as cleaners. So, Leif.
Okay.
Yeah, well, while we're waiting, would you stand and just wiggle around a little bit? There's still coffee and drinks over there. This is going to be interesting, and you're going to want to pay attention.
Yeah. No, we were able to get an early start. From my lab mates who was teaching a class this morning. The road around 11. So made good time. No traffic. Yeah. So this session, there's two other people speaking after me.
Well, one of them isn't here.
Okay.
We need you.
Okay. Oh, thank you. Yeah.
Yeah, Aaron should be here.
Okay.
This guy, Aaron, he's cool. He did some research.
Posted the movie, yeah. Yeah. Yeah.
Super 8 film, like the old, like disco.
Oh, yeah,
media.
yeah.
Cameras were always real pretty. I don't know if they even recorded sound.
Yeah.
But he did actually like one. You couldn't do any splicing, so like it was for competition. This video, and then you had to do the audio separately.
Oh, yeah.
Like, so it's
Oh, wow.
and it like pulls from his like previous research.
Yeah.
But it's done in a very art housey way.
Okay.
So really, really interesting.
All right, so Hey, can you all hear me all right? All right, even in the back. Awesome. Well, thanks for sticking around to listen to this talk. Getting late in the afternoon. I'll try not to put you to sleep. We'll see how it goes. Thanks to Rebecca for inviting me to speak here, and thanks to the lead agency for putting this all together. I will preface this by saying my research is in progress, so I'll talk a little bit about it at the end, but I also want to kind of lay the framework and hopefully give you all a greater appreciation for microorganisms and what they do in the environment and why they're important for many purposes, including remediating mine drainage. And so the main character of the story I'm going to be telling here is a type of bacteria called sulfate-reducing bacteria. I like to call them the littlest water cleaner-uppers because well, that's what they're doing, and they're very small. So let's get into it here. First off, I guess I'll introduce myself. My name is Leif Olson. I am, despite the fact that my title had incorrect grammar and perhaps a made-up word in it, I am a PhD student at University of Oklahoma. I work in the Center for Restoration of Ecosystems and Watersheds with Bob Nairn, who I'm sure is familiar around here. And some of my work is also with Cara De Leon and the De Leon Laboratory in the Department of Microbiology at OU. And you'll see some images from that lab a little bit later. So I already mentioned the names of these organisms. But before we get too into that, I'm going to give a kind of a bigger picture thing. Sorry, I'm going to set the timer, make sure I'm not going on too long here. These are some pictures of sulfate-reducing bacteria and indications of their growth from my research. On the bottom left, or bottom right from your perspective, that's a picture of them under a microscope. Not a very good microscope image, but they're just kind of these little rods, little dots, squiggly things that swim around. But we can kind of see them growing with our naked eye because of their ability to form these black deposits, which I'll get into later. But first, let's just talk about microbes in general, because they're very important and often kind of underemphasized in terms of their contributions to the human experience. So we have a biosphere, and then there's a part of the biosphere that's microscopic. And this includes a variety of organisms. Bacteria are probably the most commonly discussed and known, but fungi, protozoa, microalgae, these are all also very important types of these organisms. And they transform things. That's why I'm really interested in them, is they have this ability to take substances and turn them into other substances. People often call them nature's chemists because of the kind of experiments and transformations they can perform. So not to get too bogged down in the details of microbial anatomy, I just want to show you these images because this is on the left, it's a fungal cell, on the right, it's a bacterial cell. But there's a lot of action going on in here. So you can almost think of them as little factories that take in components of the environment and turn them into other things. And so we have the diagrams of what their cells look like, and then on the bottom, that's a microscope image showing that kind of orangish strand going across. That's a couple of fungal cells. And then those little white dots, those are bacteria, to give you an idea of, the super microscopic to the slightly microscopic. But I talked about transformations, and it's kind of a theme of this talk. So I want to run through a few types that occur in our environment. So probably one of the most well-known and common and important types of microbial transformations is decomposition, which we can think of as turning dead material, any sort of dead living material, ultimately back into soil is what will happen. And we see indications of it in these images in the kind of white fuzz. So we have a cicada, and there's all this white stuff on it, and that is the fungal mycelium. And so it's a fungus growing on it and eating it. And I just actually noticed this recently. I saw it over the past few months. Every time I see a dead cicada laying on the sidewalk, it would have this white fuzz on it. And that's ultimately going to break down the harder components of its shell or exoskeleton and turn into something that can ultimately turn back into soil. We have a similar process in the other picture. That's just a leaf pile, some mulch, and we can see this white fuzz growing across it again. And then we have a pretty good indication that it's a fungus because we have those mushrooms there. So decomposition, very important. If it didn't happen, we just have piles of trees and dead things everywhere, and it would be pretty gross, and there wouldn't be any soil to grow plants out of. Another fascinating microbial transformer are lichens. And lichens are weird because they're kind of an organism, but they're fungi and algae that symbiotically grow together and can't grow without each other. And I think they're very profound because basically they can eat rocks. And that's what you're seeing here. All those bright yellow, greenish, and kind of gray, teal splotches, those are all lichens. And the fungi in the lichens are actually able to release acids that dissolve rocks and allow them to extract the minerals and nutrients out of them. Lichens are kind of like the base of any terrestrial ecosystem because they turn rocks into their body. They transform, kind of inert, hard mineral substances into a living organism that will then die and decompose and turn into soil. So that's another cool one. What's next? Oh, these are some important microbial transformations here. This is more in kind of the human, old school biotechnology, I might call it. If we take cabbage and soak it in water the right way, then lactic acid bacteria will turn it into sauerkraut, which is it's a way to preserve food, and it's also healthy, I hear. And probably in a less healthy end of things, we can take barley and grains, add brewer's yeast, and create beer. So this is another microbial transformation, also important. Okay, but let's bring it back into Tar Creek, because this is the Tar Creek Conference. Here's just a few just random examples of microbial transformations I've observed in Tar Creek since I've been working here. On the left, those are some cattail stalks from a project that one of the undergraduates in our lab is working on, where we're trying to look at our metals being accumulated into the cattails. But you see all those kind of brown splotches, those are all molds or fungi that are probably transforming the cattail stalks into themselves and then maybe decomposing in the soil. And then in the other picture, we have this orange foam, which, like you see it a lot around here. And sometimes it's algae covered in iron, but sometimes there's no algae in it. It's just this kind of fuzzy foam. And those are actually mats of what are called iron oxidizing bacteria. And the transformation that they're doing is they're taking the dissolved, reduced iron and then oxidizing it and turning it into a solid precipitated form, basically rusting it. And even though a lot of the iron oxidation happens without the help of these organisms, they're more just kind of there to take advantage of it when they can. That's another example, and now we're getting kind of into how are these organisms involved in potentially remediating some of the contamination issues that exist. And so now I'm going to segue into the real meat of the talk, talking about a type of microbial transformation that I've been fascinated with for a long time. We can call it bioremediation in general, but it's basically the use of living organisms to clean up pollution, leveraging the properties of life that allow them to take toxic things and make them not toxic. And I will note that bioremediation is kind of all-encompassing of all life forms. It's not limited to microbes. If you're planting things and using a plant to remove metals from soil, that's also bioremediation. And for these images here, we have this orange water coming out of the ground at one of our research sites, and then it turns into this nice, clean-looking wetland water. And microorganisms have a role to play in that process. And that's a lot of the work at the Crew lab that we do, is trying to leverage natural processes, biological and non-biological, to treat the mine drainage with what we call passive treatment systems. And they're called passive because they're not actively pumping things, they're not actively adding chemicals. It's more creating different types of ponds and reactors, we call them, that have different properties to remove the various metals. So here's a bird's eye view of the two systems that we work with in Commerce up the road. We have Mayor Ranch on the right and Southeast Commerce on the left. And so these are a series of different ponds, going from open air ponds to wetlands to what we call vertical flow bioreactors. And each successive step will remove different metals more effectively than others, but the idea being that in combination, the water coming out of the system is clean, and it leads to improved ecological health downstream. And we've monitored this as well, as there are recoveries in fish populations and kind of anecdotal observations of furry creatures like beavers and river otters moving in to where they didn't live before. And so these vertical flow bioreactors are called that because the water flows from the top down through the bottom, which forces the water to go through a anaerobic zone. So these systems are more generally called anaerobic bioreactors because they don't always have a vertical flow design, or they're also called sulfate reducing bioreactors because that's the biological process that they're trying to promote. So the original idea and design of these systems is based on natural processes that occur in wetland sediments, but the system is designed to amplify what would happen in a wetland sediment by increasing the amount of carbon in the system, which will feed the microbes. Having a lot of sulfate, which we don't really have to worry about adding sulfate in these settings because there's a lot of sulfate in the mine drainage, and having less oxygen so that we can promote anaerobic organisms that can live, I should say that can live without oxygen, but also that a lot of them are sensitive to oxygen and won't do well if it's around. All right, so mushrooms. What does this have to do with any of it? Well, this is part of the system. So we're going to go through a little tour here over to JM Farms up the road. They produce like, I think 500,000 pounds of mushrooms a week or something. But are you all familiar with where the button mushrooms come from and how they're grown and what they grow off of? So yeah, this is another little microbial transformation happening here. So I heard some stuff about chicken manure and straw. Yeah, and I think their recipe, they're constantly kind of reiterating it and improving it, and like they'll add things like beet pulp and other materials, but ultimately to create this, it's a type of compost that the button mushroom, the one in this box, that might be a cremini. Cremini, portobello, white button mushrooms, they're all the same species of fungi, Agaricus bisporus. They're just grown different ways to look, different ways to please the consumer. But they're all grown by making this compost, and then the mycelium grows on it, like the fungal's body, kind of the roots of the fungus. And then, if it goes well, you got these trays full of mushrooms, and there's lots of them, and then they harvest them off these things, and the mushrooms keep growing. There's lots of mushrooms, and even more mushrooms. They grow a lot of mushrooms over at JM Farms, that's the point. But eventually the mushrooms stop growing. And once the mushrooms kind of stop growing, well, the mushrooms are still growing, but once the substrate's been growing long enough, they want to get it out of the fruiting room so it doesn't contaminate it with molds and things like that. And then we end up with what we call spent mushroom compost, this pile of material that has the virtues in our bioreactor system of being very rich in complex carbon sources. So we'll end up using it to help facilitate the growth of different types of microbes. So now we're going to get into how the vertical flow bioreactor is built. You dig a big hole in the ground is the first thing, and then put a liner in it and put drain pipes above the liner. And so this is making it, like I said before, so that the water comes into the pond, but it has to go through the bottom before it gets out. And they bury those drain pipes in that mushroom compost, also mixed with wood chips. My advisor will call them wood shavings, but they're chips though. He might get mad at me for saying that. But then we fill it up with water and let it happen. And this is what it looks like 10 years later. It's transformed into this black muck, and that black muck that's where the sulfate-reducing bacteria live. That's where the action happens. And this is where a lot of metal removal happens. And that's what I'll get into next, now that we've laid out what is the system. Microbes are important. What's it made out of? And this is what it looks like last month, I believe, is when this photo was taken. So it's still there. So on the surface, it just looks like a pond. But because the water has to go down through the bottom, it loses all of its oxygen in the process. And then it makes what we want to happen in the system. So let's talk about the, it's been a while since I talked about the sulfate-reducing bacteria in detail. And now we're going to get into a lot of detail. So I see some people are drifting off, but that's okay. You can come back when it gets entertaining again. Okay. So these organisms were first discovered by a Dutch microbiologist, Martinus Willem Berenck, I believe. I probably pronounced it wrong. But he was trying to figure out how to remove calcium sulfate from canal water somewhere in the Netherlands, maybe in Amsterdam. But the idea was to make the mineral content of the water lower, so when they put it through their steam boilers, it wouldn't clog them up. And it was 1895 when he described the first species of sulfate-reducing bacteria. And in general, these organisms are important because they transform metals from a soluble, kind of mobile in the water form to an insoluble precipitate that doesn't move in the water. So it's interesting because we're kind of trying to leverage these organisms to remove metals from the mine drainage, but ultimately it's the kind of the same purpose that they originally studied for, is to get minerals out of the water. Different context, different setting, but it's going back over 100 years, this is kind of something they've been known for. So now to get into some fancy chemistry diagrams. First of all, they perform what we call anaerobic respiration. So aerobic respiration is what we as humans and animals do, where we breathe in oxygen and exhale carbon dioxide. But what these organisms do instead is they breathe in sulfate and exhale sulfide. And reducing is a chemistry term for adding electrons to a substance. So sulfate is being reduced into sulfides, which sulfides are actually kind of toxic and can be a hazard in their own way. But the thing is, they have this property where when they encounter dissolved metals, they have a high affinity to bind to them and then turn them into a solid form where they're not floating around in the water anymore. So that's what these two diagrams in the bottom are showing. On the left, that's the sulfate reduction, which you see part of this is a carbon molecule, which is why we need that mushroom compost. And it produces the sulfide, that H2S, and then that H2S binds with the metals and turns into a solid form. And when iron sulfides are produced, when the sulfide binds with iron, it creates this distinctive black, kind of visual indication. So it's a good way to potentially tell if sulfate reduction is happening. And that's what's happening in this Petri dish here. And also, if we go back to the H substrate, it's pretty dark. So that's probably the iron sulfides being created in it as well. Now we can go to the super micro scale. This is electron microscopy being done here on metal precipitates from substrate from the Mayor Ranch treatment system where we work. So on the right, you can see the zinc sulfide are those kind of round ball orb things. And then in the other picture, we have these kind of tetrahedral looking crystals, and those are iron sulfides. So this is the actual formation of a physical solid. And this is important because basically the water that flows through the bioreactor transforms the metal into this form, and then it gets stuck in the substrate. And then when the water leaves, it doesn't have those metals in it anymore. So these organisms are very diverse. There's whole sorts of types of them. They exist on different parts of the tree of life. They didn't all just evolve from the same lineage. So they're kind of everywhere that they can survive without there being an excess of oxygen. And they can have different shapes and look different ways. Some of them have tails like that one on the bottom. Some of them form spores like the one on the upper left. So getting into my research, part of the goal is to try to go to these systems where we know there's a lot of sulfate reduction going on. We know they're removing metals from the water. But we want to try to figure out, like, who are these characters and what are the ones growing in the mine drainage treatment bioreactors? What kind of capabilities do they have? Do they have special adaptations to growing in the metal that makes them, better at this than varieties that come from uncontaminated habitats? So for growing these out, there's kind of 3 main steps that I had to go through. One was collecting samples, then what we call the enrichment, which is this is where you put the wild sample into some material to try to get organisms to grow, but then you have a diverse community, and then the next step is to try to isolate an individual strain so that then I can say we have this one species, this one type of organism, and now let's do some tests on it and see what it's capable of. So for sample collection, we're still working on developing sample collection methods. We couldn't come up with any better ideas before this, so we just got in the pond and tried to pull it out. And maybe that wasn't the safest method, but got the samples. And if you look on the picture on the right, we came in with like a little test tube, shoved it down in that mushroom compost substrate, filled it up with material, and then stuck that into this box, which has an anaerobic or antioxidant packets, I should say, to try to reduce the amount of oxygen getting in. So when I transport it back to the laboratory at University of Oklahoma, hopefully they haven't gotten stressed out too much by being removed from their native environment. So then we have the box there back in the lab and those little dark test tubes. And because these organisms are very sensitive to oxygen, we've got to do all the work inside of this anaerobic glove bag, which is basically like a plastic bag that has nitrogen gas pumped into it. So instead of having oxygen, there's nitrogen flowing around in it. And once it's in there, we take the samples, create kind of slurries out of them, and then get syringes, pull some of the slurry out of the syringe. So this is like our little aliquot, little sample of what was the mushroom compost bioreactor substrate, and then inject it into test tubes that have a specified growth medium. You can kind of think of it like Gatorade because it's got like all the good vitamins and minerals, but it's Gatorade that is designed to only have this type of bacteria grow in it. And then we let them sit and wait for them to grow, if they do grow. And we look for visual signs of growth, which in this situation is any of the black stuff. Those are the iron sulfide precipitates I was talking about. And then also you look for cloudiness, because if you see cloudiness in the tube, that's usually indicates that there's a bacteria colony growing in it. But like I said, at this point, there's still probably a diverse group of organisms growing in here because we just took the sample from the environment and threw it into the tube. So now we got to isolate that from all the other ones. And so I take that tube, put it back in the glove bag, and you can see there's the gloves there. It takes a lot of like hand dexterity to do this, especially because the glove bag they let me use has extra large gloves and I have medium hands, so it's kind of like got to make sure not to stick the tip of it into the wrong place and contaminate things. But we take that enrichment culture tube, pull out a sample of that with a syringe, and then we have this what we call agar, which is it's liquid right there, but then we pour it into Petri dishes and it turns into a solid version. So now we've taken that enrichment sample and then added it to Petri dishes with a special growth medium, and then we let them incubate again because these guys don't necessarily grow super fast. And once they've grown enough, then if you see the picture on the left, we have those black dots there again. And so that's what I'm using as the indication that, aha, we have a colony growing here, and hopefully it's an isolated colony. And then I take a sterile toothpick and dip it into those colonies, and then put it into another tube of our special Gatorade formulation, and then wait for it to grow. And if it grows well, then we have an isolated strain, and that's what the picture on the right is. I will say, though, this is not a foolproof process. I think I did this. I made 72 different cultures doing this, and of those, 16 of them were actually isolated strains. So just because you've gone through all the procedures doesn't. Bacteria are tricky, and there's some that like to attach to others and feed off each other. So now I've got about 16 strains. I'll probably pick out about half of them to start doing some characterizations on like what kind of properties do these organisms have. So like I said, that's about as far as I've gotten in the research, and in the coming months I plan to start doing some tests to see how metal tolerant these strains of organisms are. So I'm going to grow them in those tubes again, but instead of making it like an ideal thing for them to grow in, where it's like, we want you to do well, we're going to do that, but then we're going to add in lead and zinc and then at different concentrations and see how much can they tolerate, and then try to compare that to other types of these organisms, other sulfate-reducing bacteria that are not from contaminated sites, to see, are the ones from the mine drainage treatment reactor better adapted? And then to follow that up, we'll also do genome sequencing to see if they have what we call metal resistance genes, which are basically parts of their genome that can create proteins or materials that help them survive with high amounts of metals, which that's what this fancy diagram on the upper right is showing. It's just bacteria can adapt to metals in different ways by potentially like pumping extra metals out of their cell or transforming them in their cell. And there's usually genes that are associated with this. Yeah, so it gets to the main research question: are the sulfate-reducing bacteria from the treatment system specially adapted to the metal pollution they're remediating? And in terms of the implications of this, if the answer is yes, then this might lead to some interest in if we build another passive treatment system to capture, maybe some of the seeps of Douthit, which might happen in the future. Is there potential to take the existing material from these bioreactors that we know has this community of specially adapted super remediator organisms and adding it to the new one so it kind of gets geared up and starts happening faster? And then there's always the potential bioprospecting, which is that's a term for when we find microbes that have special characteristics and then try to apply them for other things. Like if these organisms are metal resistant, a lot of the genes that make them metal resistant might make them good at remediating other pollutants. And I probably won't get into that in my research, but that's always something people are kind of looking out for with doing applied microbiology type of work like this. And yeah, that's it. I gotta acknowledge my research advisors and my collaborators, other graduate students who've helped me with this work, and our partners who funded the work, the GRDA and the DEQ. So thanks for listening. There's my email if you want to ask me anything or get in contact later. But in the meantime, I guess you can ask questions or comments now if you have any. Mm-hmm. Yes, that's every time I've ever spoken about remediating metals, someone always asks that question. She was asking about the ultimate fate of the metals. They're getting removed from the water, but they're not disappearing because metals are elements and you can't just destroy them. So yeah, they are being sequestered in the substrate of the bioreactor, and occasionally we will test the concentrations of the metals in the bioreactor substrate. And as of a couple years ago, the last time we did a comprehensive analysis in it, the level of metals in the substrate does not exceed any like hazardous materials guidelines at this point. So maybe in the future it will, but the oldest system's been running for 15 years. And so the metals are getting stored in there, but it doesn't appear that the material has passed any threshold of being a hazardous substance. Maybe it will one day, and I guess ultimately if that were the case, there might be a need to take out the substrate and dispose it like a hazardous waste facility, but there hasn't been a need to do that yet. Yeah.
Solid or like solid metal substrate.
Yeah.
Well, not solid metal, but you get it. A solid from the water. Is there like a timeline or a projected like expiration date for when the passive water treatment system will like dredge up or silt up like a dam where it will no longer be able to like effectively
Yeah, so she asked if there's a timeline with the system kind of absorbing the metals if it starts to get clogged up and have issues with functionality. And yes, that does eventually happen. These systems, I think, are usually designed to have like a 10 to 20 year lifetime before you're supposed to replace the substrate. We haven't done that yet, but we did, at some point we were having flow issues in one of the bioreactors. It wasn't draining very well and the water was getting backed up, and we didn't replace the substrate, but we drained the water level down, and someone came in and dug it up and kind of flipped it over and stirred it up to kind of loosen up kind of blockages in it. So that, we've done that, and you know, in the future we might need to replace it. But these systems, passive treatment systems, are usually designed to, like, the initial system is supposed to run for 10 to 20 years, and then it should require some maintenance at some point of potentially dredging or removing materials, replacing materials. And that's true of multiple components of the treatment system, not just the bioreactor. All right, you, and then you.
I may be misunderstanding the process a little bit here, but it sounds like it might result in the mushroom
Compost entering the watershed? Is that a concern?
Not really, because this is not the last part of the treatment system. If you saw, like, on the diagram earlier, there's a series of ponds. And so the water flowing through it, it's going through pipe, like perforated pipes on the bottom of the pond, which the solids don't really make it through that in general, but the water is anaerobic at that point, which is bad for, like, stream health. But so these systems are always followed by what we call it, like, a polishing unit, where it goes to another open pond where it can get oxygen back into it and kind of just passive natural filtration, where it drains into that and then usually drains into another unit before it actually gets discharged in the creek. So there's a couple more steps to try to, like, catch residuals and re-aerate the water and things like that. Yeah.
This is admittedly a little bit of a geek side of things, but I'm wondering, over the course of, say, 10 years, the nature of the carbon pool that's available is getting more recalcitrant, I would guess.
Yeah.
So are you seeing a diminished rate of reaction as the carbon is being more processed over time by the bacteria?
That's a good question. He was asking if the carbon is being transformed over time when the process is running, and then is it going to lead to more recalcitrant or kind of harder to access forms of carbon. And I haven't done, like, a deep dive analysis on the removal rates of all the metals throughout the system's whole functioning yet. But it's still, the treatment rates have pretty much maintained the whole time, except for when we have O&M issues. But that is something I'm planning to kind of assess more in terms of what years of operation is the treatment efficacy for different metals changing. And I would imagine that that there's probably less labile carbon available as time goes on. And that's probably, in addition to, like, the clogging and hydraulic issues, addressing her question, that's probably another reason why, 20 years down the road, you might want to replace the substrate, because it probably has lower quality. And I didn't mention it here because I wasn't getting into the whole microbial community of the bioreactors, but it's not like the sulfate-reducing bacteria, they're the ones that are actually removing the metals. But there's a larger community that's important for these systems to function, because, like, the sulfate reducers can only use really simple forms of carbon. So there needs to be other, like, sugar fermenters and cellulose degrading organisms that can break down the more complex forms of carbon into a simple carbon for them to use. And so I would also wonder if over time, if the carbon becomes more recalcitrant or harder to access, if the microbial community might shift towards organisms that are more capable of breaking down complex bonds. Yes.
I have a much less science-y type question, but more trying to understand type question. But you mentioned that you were interested in whether the sulfate-reducing bacteria that you culture, right? Whether they are more resistant to metals. whether they were more tolerant to metals, I should say. So if they are, what's the takeaway from that? What's the significance of that? And if they are significantly more tolerant, what does that tell you about the use of other varieties of bacteria in similar processes?
Yeah. So I'm gonna make sure I'm getting your question right here. You're asking about if these organisms are more tolerant to metals, what's the significance of that? And also for applications, maybe in other settings with other types of organisms. And it's generally thought that most organisms, especially microbes like bacteria and fungi, if you find them growing in a contaminated site, they probably have developed some resistance to the contaminants, because like in the research literature, it's often noted that these sulfate-reducing bacteria are sensitive to metal toxicity. They're like, if you just take random varieties that you go from, like a clean lake sediment, or from, they live in the human gut, and if you get them from there, they're not necessarily going to be able to withstand high concentrations of metals. And so the hypothesis would be that, yes, the ones growing in the mine drainage pond are going to have higher metal tolerance because they're there, and it's like pretty straightforward anecdotal evidence. But if with trying to conduct science of stuff like this, like you can't assume that's the case until you actually prove it. So that's kind of step one, and to see, if they are adapted. And that I mentioned some of the genetic research I'm planning to do. That's trying to get into like, if they are adapted, why? Like, what is it that they're specifically doing? Do they have a better ability to like pump metals out of their body? Do they have a better ability to like form, like chelate or immobilize metals outside their cells so they never take them up in the first place? And so part of it is kind of that's more of like a theoretical framework in terms of just like understanding the science of it better. But in terms of, if we do demonstrate this, it's the like why, like who cares, what's the point side of it. The idea is that these types of systems could be reservoirs for biological material for doing more remediation projects at other sites, potentially more mine drainage remediation, I think I mentioned earlier, because when you put the mushroom compost, or it's not always mushroom compost, sometimes people use straw or manure or other materials, but when you set that up and flood it with water, it's not like, boom, you've got the microbial community to remove the metals. It takes time for that to develop. So if we can kind of demonstrate that, yes, these organisms are specially adapted, then this could be like a reservoir, a resource. So like, oh, you have a project where you want to have bacteria that are adapted to metals and can remove metals. Let's go grab some from here and put them somewhere else. And then, I mean, that's kind of a general concept of any sort of bioremediation. Like if you want to, find a fungus that's good at breaking down oil contaminants, you probably wouldn't want to like take the mushroom from JM Farms. You'd maybe want to go to like an oil spill, and if you can find fungi growing there, try to grow those and use it. So, and that kind of gets into the bioprospecting concept of like, we know that we have interesting, well-adapted organisms living here, and maybe we want to do the same application somewhere else. Can we accelerate the process by, instead of, because if you don't do that, then usually enough organisms will eventually form to clean up the problem. It's called natural attenuation, but perhaps we can accelerate it to make things happen more efficiently. Yeah.
Pictures of, like microscope pictures of the zinc and the iron.
Yeah.
Is it the same process for lead?
Yes, she was asking with these, where are they? The metal sulfide precipitates, if it's the same process for removing lead. And as far as I know, it is, because it goes to this this chemical reaction here, in the middle, the metal sulfide precipitation. I guess it applies mostly to divalent metals, so any metal that floats around with a +2 charge will have an innate affinity to bind to the sulfide. So it basically, and there's different, like, not to get too deep into it, but different metals, like thermodynamically, are more favorable to bind into metal sulfides than others. So it's not like they're all equal, but it's the same general process. And Rebecca asked me to mention that I'm also planning in the future to do some studies with microbial community analysis and some of the mine drainage affected wetlands, potentially comparing some of the treatment wetlands that we have with some of the natural wetlands. So that might be something I might talk about here next year, depending on how things go.
We have a wetland for you.
Okay, nice.
Yeah.
All right, well, thanks everyone. I appreciate your time. Hopefully it wasn't too boring. Well, thanks. Yeah, I guess the thumb drive's already out of here. Oh, thanks. Yeah. All right. All right, I'll work on that.
Thank you. Wow. So you thought we were done with chat, but we are not done with chat. We're still chatting. I was contacted a while back by a fellow that said, 20 years ago I did some research for my master's on chat, and now I want to make a movie. I said, okay, well, you should come up and we'll help you make a movie, or whatever. So I want to introduce you to a chat researcher, now filmmaker, Aaron Gibson. Are you in the room? You're right. And have you helped him? Okay, he's helping. He's coming. So that's the best introduction I've done all day. I didn't mess up with your name. I pronounced it right. I told a little history.
Perfect. Thank you. Do you want to show right away, or
It's you, man.
okay?
What's the best player that you
Do you have QuickTime?
I doubt it. DLC?
Yeah, it should show on DLC.
DLC? That's also a good one.
Hey, everybody. While we get this queued up, I thought I'd just introduce myself real quick. My name's Aaron Gibson. I'm from Norman, Oklahoma.
I was just talking about how VLC was wonderful.
Yeah. Should be able to do space bar. Let's see if it'll stop. It's a false start. No problem. Like Rebecca said, I went to the University of Oklahoma, and my master's was in environmental epidemiology and toxicology. So I was working on my master's thesis, and at the time it was Robert Lynch, or Bob Lynch, Dr. Lynch, which he's maybe been here before. I'm not really sure. Okay. All right. And it feels strange now, being here 20 years on, being at the Tar Creek Conference, when I probably should have been here a long time ago. My master's thesis back then was on particle size distribution and metal concentration in mine tailings. So it's interesting when I listen to your talk, there's a lot of similarities between what I looked at. Of course, I didn't look at the migration of chat and those kind of things, but I was looking at the concentrations, and I found similar results in that the higher concentrations were in the smallest particle size. But anyway, so I moved on in my career and started to do other things, but I never really got the area out of my mind. And as I kind of progressed into filmmaking, always been fascinated with filmmaking and telling stories, and I'd never really done a documentary type film. And I started to think about what would be a good story, what would I be interested in, and I started thinking about Tar Creek again. And so did some research online, tried to get caught up a little bit after a couple of decades having not been to the area, and just was interested to read about the history and some of the other research that was being done. And I quickly found lead agency, and I found Rebecca and read some stories about her. And so I reached out and kind of explained what I wanted to do. I didn't want it to necessarily be my perspective on the region. I didn't really feel that was appropriate. I wanted it to come from somebody who was here. You know, this was their home. So I felt that I'd found that in Rebecca. I felt that I'd found somebody who could really speak to what it was like to be here, and really, in essence, speak from Tar Creek, like be the voice of Tar Creek. And essentially, that's what this is intended to do. So we'll just go with that. And do I need to just hit play or what? Space bar. Okay. Do you need to turn out the lights? Oh, right. That's also worth mentioning, too. Okay, I could talk more about it afterwards. So this is actually what I call the revisited version, or somewhat of a director's cut. The initial version that I did was specifically for a film festival in London that had very strict requirements about what you could edit. And in fact, everything that had to be shot in sequence, so it could not be edited, which makes it a challenge. That's part of the festival itself, is to be able to shoot something sort of in order. But it puts a lot of restraints on what you can do creatively, too. So I wanted to come back to it and edit it in a way that I felt was more appropriate and would tell a more holistic story. So this is an expanded version and has more footage and a broader story. Okay.
There was a time before, way back, the mining that occurred around me was an effort to pull from the earth essential elements that were needed for economy and for winning wars. We were essential. We had beneath us essential elements. They left behind what they didn't want. They left behind what they couldn't use. They left behind what they couldn't sell. They left behind what they couldn't make money with. They left behind what harms me, but they left behind the stuff that harms children. And it flows down me every day. And it goes down my stream, my water flows into a river and then flows into a lake that people drink. And the fish that live there are harmed by what they put into me. They left behind the war zone that never has been repaired. If all the people that had come through all these years had all taken a bucket full of this stuff away from the edge of my life, I would be better. But they didn't. They studied it, they looked at it, they pondered it, they figured out what they could sell, how they could please people, how they could use that waste to benefit companies, to benefit a cheap source for the state to use. They've used it in every which way. So the Quapaw, the Peoria, the Miami, the Ottawa, all got land that lay beside me. And I stain each of their lands now and poison the plants that grow along their banks. What's happening now around the world is the great search for new elements. These elements are in the earth, near streams, near creeks, near rivers. These areas are going to be wounded. They're going to be wounded like I am. These essential elements that hide near you will feed the new industry, the green industry of the future, and poison the people you care about. And what's been forgotten is that water itself is life and provides it without guile. Neighborhoods, tribes, peoples of the world are going to have to understand that they can be damaged for generations, for decades, if they allow their tar creeks to be damaged. I would say to every creek out there, holler as loud as you can to be protected. This is your moment.
Two sides of the same question, right? If you were to do this project again, I know when you came up with the idea, you were submitting it to a festival that said you have to use Super 8 film, right? Two questions. One, Do you think that that media particularly suits this subject? And if so, sort of how? And if you were doing this from scratch, not having done anything, and you could use any media you wanted for this, would you choose different media other than Super 8 film?
I like Super 8 film, and I shoot on Super 8 film pretty often, so this kind of lends itself to that type of media. I think it has a real authentic quality to it, and you get sort of a different color range with it, a different movement with it. So I would prefer to shoot on Super 8 film for something like this. I think the only thing, if I could continue to develop more, I would probably add in some animation effects and some actual kind of drawing and animation type stuff to it too. But I just really enjoy shooting on film, so that's the way I would go. Yes? Yeah, well, thank you very much. With the audio, I would note too that that was all in one take, and that was at the lead agency office with, that's probably the poorest quality, and the thing I would improve the most is I'd have better audio quality, because I was not prepared for how noisy the office was. But that was all one take, that was basically just Rebecca and I talking, and she could speak to what that was like, but I felt like it was really kind of channeling what it was like to be in the position of Tar Creek. So, anything else? Yes. Oh, way back there.
So thank you. That's a beautiful film, and it's a powerful showcase for Rebecca's voice. Was that a script
No.
that was written and read in the office, or that was off the cuff riffing on channeling Tar Creek's voice?
Yeah, that was just channeling, and really the conversation we had, I think, was more like 40 or 45 minutes. So it was, pared down from that. But no, not on script at all.
So the filming was all in one take, like one scene after the other, but the audio was edited
Right.
into it. Okay.
Right.
Well, it's magical. Thank you.
Oh, thank you.
What are some of the other limitations that they put on you when you were putting this together?
So the film festival that I've entered several times now, it's called the Straight 8 Film Festival. It's based in London, and basically you have a single cartridge of film that you buy. The first shot has to be your entry number, so which you don't see. I was able to edit that out, but the first shot has to be the entry number so that they know that you didn't do any editing, that you just started with that single shot with the entry number, and then you go from there. So the only thing you do get to edit is the audio, but you don't actually see the film to edit the audio too. You turn in the audio track, and they sync it up, and then they show it for the very first time at the festival. So that's the first time that the filmmakers get to see it. That's the first time the public gets to see it. So it's really challenging. So if you compare this version, the revisited version, to the original, which is about 3 minutes long, then you can see quite a few differences. But the other footage came from a return trip to Tar Creek and shooting more footage. And, my wife, who's back there, put her in the film, put my son in the film. It was very much a family film. And then Rebecca's son, Dana's in the film. So, again, just try to incorporate whoever I had access to. Oh, and myself, yeah, of course. Any other questions? Yes, sir.
Not a question, just like, I think that was so personally was the t-shirt.
Oh.
It's so powerful because I think as a scientist you can become so comfortable with PV as the notion of an element, and it's so abstract, and I think, okay, it has 82 protons in it, right? And then when you put that on a person, right, then you really personalize the impact of that element on your watershed. And I found that incredibly powerful, but
Mhm.
I absolutely love it. And then the other piece that I thought was Rebecca's narration about a warning to others. So this was not just a reflection of what happened in this watershed, but as we go and look for lithium and other elements that are different than the elements that from the last demonstration, what's going to happen. So that gave me chills.
Yeah.
I feel like it makes this much more than just about
Right. I agree. Yeah, it was an interesting thing to come from the world of science and having that understanding and being here from that perspective. And I distinctly remember whenever I was doing my thesis research, and Dr. Lynch, who was my advisor, I explained that I wanted to do something more than just the research. And I even suggested back then doing some kind of film, and he's like, "Oh no, don't do that. You know, not going to get any extra credit for that." So I don't know. There was just something where I just felt like, we all of us here who have done research and are involved in science, it's like you kind of do the best work you can and you pass that along and you hope that others are able to build on it. You hope that something comes of it, but you don't know what kind of impact you're really making, in the larger scheme of things. So for me, this was a way, I think, that combination of the science part, the policy part, the communication part, to get a message out there that wasn't just science, but still rooted in science. So, yes. Yes. So I'm still looking at other places to show it, but eventually I'll have it on YouTube. We'll send out that address somehow. All right. Thanks, everybody. Really appreciate it.
That was amazing. Really, really touching. And we're going to show it again tonight at 7 p.m. Yep, just down the way. So after, and actually, I should say, Rebecca, why don't you come on up here? Let's do a quick preview of what happens. We're coming up to our last presentation of the day, but afterwards, we have some other things. And Rebecca, I'll let you pitch that.
Okay.
After at 5 o'clock.
Right. So the coolest thing ever is you think you're over, but you're not over. And you think you're done, and you think you can leave, but there's so much more to do. So at 5 o'clock, we'll have an Indian taco dinner, which may be 5:15. Anyway, it's coming. And but we're also having the open house that starts at 5 to 7. And so we have EPA has come in. You'll have different people around the room that we want you to have time to visit with, because I have not given you time. Each of them have stories to tell, things to share. They want to tell you about what they're doing here or what they hope to do here. And then at 7, we will have the movie. We will show the movie one more time in the little theater that's just outside the side door into the next building. It's a small little theater. I think it'll be very intimate, and it'll be wonderful to share that with you there. Okay?
Okay. Thank you. So hope to see you folks at those. So earlier in the day, we heard a lot about flooding, and we heard several references to FERC, Federal Energy Regulatory Commission, and the role they play in relicensing the Pensacola Dam. Well, it just so happens we have someone from FERC to tell their part of the story. And Amanda Bradshaw arrived here just, an hour ago? More or less an hour ago. And she is with a really interesting office at FERC. a newly created, just in the last couple years, 18 months, year and a half, called the Office of Public Participation. And she's going to give an overview about FERC, what they do, the hydropower relicensing process, and how all of us can play a part in that process. Now, before I have her come up here, I'm going to say one really important thing. Because there's a pending matter regarding the Pensacola Dam before FERC, she cannot answer any questions about the Pensacola Dam. so we can ask questions, but there may be some where she kind of has to back off a little bit. But all that being said, I'm really excited to have Amanda here with us today. And please come on up and introduce yourself. Absolutely, in general, yes. Yes. So yeah, I said it all the time. So yeah. Thanks for coming out.
Oh yeah, no, thank you.
What's your presentation?
It should be called, let's see here, OPD presentation right here.
OPD?
Yeah, there it is. I really want people to associate it with the song.
You know me.
Yeah, exactly.
I think you gotta be 40 years old.
I don't know about that. Yeah.
While the presentation's getting ready, I'll introduce myself again. So I am Amanda Bradshaw. So I work at the Federal Energy Regulatory Commission, also known as FERC. I just flew in and drove a minivan all the way from the Tulsa airport because that was the only car they had for me. So it was a very big car and also hard to drive because I normally don't drive a lot in Washington, D.C. But I'm here now, and thank you so much for inviting me to be here. My boss actually is one of the, or used to be one of the core people leading the licensing for the Pensacola Dam. So it's an issue that's very near and dear to her heart. But because she has continued on serving on that case, she wasn't able to be here and be the person talking for the reasons that Martin mentioned exactly. Her name is Rachel McNamara. Mm-hmm. Yeah. But yeah, thank you again, everyone. So I come from FERC's Office of Public Participation. And as Martin mentioned, we're kind of a special office that was just installed a little less than 2 years ago. And we're really here to be that person and to be that office to connect you to FERC. If you have something, a reason that you want to engage at FERC, if you are affected, like the Pensacola Dam, and you simply just want your voice heard because you feel like you need to get relief from decisions from FERC. So first off, I have to do my standard government disclaimer. I do not represent FERC, even though I work at FERC, but I have to say that. So all of these views are my own. They do not represent any of the commissioners that are at FERC. So again, kind of going back to what Martin said, I just want to give a little bit of some background about FERC. What is our agency exactly, and why does it matter to you all that are here today? Also give some background about our Office of Public Participation, why that kind of separates us and sets us aside from the bigger agency at large. Also a little bit about FERC's role in the hydroelectric sector and what we do in terms of licensing hydroelectric projects in the U.S. And then kind of putting these pieces together and why does this matter to you all, and how you can use a lot of the research that I've already heard today. I've been here for an hour and I've already heard a lot of studies going on and people researching these issues, how to get it at FERC in a way that affects things like licensing and relicensing hydroelectric projects at FERC. So just a little bit of a background, we are an independent regulatory agency, so that kind of sets us a little bit apart in the federal government way of things. So you've probably heard of Department of Energy or DOE. We're a little different because we're an independent regulatory agency, so that makes us have a sitting round of commissioners. So we typically, on a good day, have 5 commissioners, but a lot of, our leadership is at the whims of a lot of the politics that go on in Washington. We currently have 4 commissioners right now, led by our acting chairman, Willie L. Phillips. And we're supported by a ton of different offices because we do a lot of different things in the energy sector. Besides hydroelectric projects, we do regulate the electricity sector. So if you're walking around your neighborhood and see really big transmission lines, those are high voltage transmission lines which underpin a lot of the energy that gets delivered to our homes and businesses. That's also a FERC thing. So if you care about that thing too, please talk to me afterwards and I'm happy to answer any questions. So the Office of Public Participation at FERC was established a little less than 2 years ago, and we are definitely the new kid on the block. So we were actually on the book since the late 1970s, where folks, surprise, surprise, realized that FERC was a very tricky agency, but an important agency to deal with. And so Congress told us to establish this office back in the 70s. But it wasn't until recently, 2 years ago, where Congress actually gave us the funds to put that agency into practice. So a little late in coming, but we're here now. Half of the office, so including myself, so I came from a previous office where I was an analyst. I was analyzing a lot of the filings that come into FERC, applying the kind of standard of review and the judgment that we analyze filings with. But then I came and moved over to the Office of Public Participation because I felt it extremely important that the public get involved at our agency, that we have a really important role, even though that role isn't always very transparent to the public. A big part of what we do is direct outreach and education, so we try to get the word out in terms of FERC's role for different matters, which is why I'm here today. We have a lot of regional office staff who are placed around the country so that they can be an in-person resource for folks who have similar issues with hydroelectric dams, with other kind of energy things going on that our agency is in control of. We also do a lot of internal work, so we are, kind of set in our ways in many ways, and so our office was put into place to precisely collaborate with other offices who are set in their ways and might not see public input as really essential to our decision making. So we do a lot of that work talking to folks and telling them why we need more voices on the record to result in better decision making. So I just wanted to give a little bit of an overview too of our hydroelectric programs. I'm not going to go into any details, so a staff member from another office would probably give you something more in depth. Today I just wanted to give you a little bit of the flavor of what we're in charge of at our agency, just to give you some of an idea, and if you have questions afterwards, feel free to ask me, and we can also put you in contact with folks who work precisely on our hydroelectric program issues. But just for a little bit of a background, so FERC regulates non-federal dams like the Pensacola Dam. So there are many other federal agencies in charge of hydroelectric dams. And so for the ones that they're not in control of, where it's a utility company or a private company or a private individual, FERC regulates those dams. So it allows for permitting to take place. So these companies that need to start looking at construction and how they're going to build these dams, to issuing the license, which is a very long and lengthy process, which ultimately results in a 30 to 40-year allowance to operate a hydroelectric power plant, with relicensing coming up, which is the case of the Pensacola Dam. So just a little bit of background on the technology. So there are many different kinds of hydropower technologies. The Pensacola one is a conventional hydroelectric power plant where you have a reservoir that water flows through through turbines, which generates electricity. But there are many other kinds of technologies these days, such as pump storage, which kind of utilizes a reservoir at the top, and water gets pumped up, and water gets, during when electricity is demanded, it flows down and generates electricity. There's also really interesting use of technology these days with wave and tidal energies, where you basically put a piece of technology in the ocean or in a running body of water, and it really harnesses that kinetic energy and generates electricity. So there's many different technologies, but definitely the conventional way is the way that we see most hydroelectric plants these days. Just some pictures. So a lot of the jurisdictions, so when we talk about jurisdiction, we talk about, what kind of authority does FERC have as a federal agency over hydroelectric plants? So a lot of that authority or jurisdiction comes from a thing called the Federal Power Act. So that is a set of regulations given from Congress to our agency to implement. So Congress has basically said, hey, FERC, here's a set of rules in terms of managing the electricity sector, in this case, hydroelectric power plants. You as the agency have the ability to enforce or implement those rules. And so just in terms of the actual definition, the Commission authorized non-federal hydropower projects that are located on navigable waterways located on federal lands, using surplus water from a federal dam, or located on non-navigable waters over which Congress has the Commerce Clause jurisdiction, were constructed or modified after 1935, or affected by interstate or foreign commerce. And because it is a big book of regulations, there are more regulations that are subsections of those regulations. There's various parts, and so when the relicensing, so the current state for the Pensacola Dam is that, it's been given an extension until, I believe 2025 is, what is it, yeah. So until 2025. But when it does really hit those relicensing procedures again, it's going to have to be studied and analyzed under a lot of these typical requirements. So when you look at a hydroelectric power plant, the Commission looks at it and tries to give equal consideration. There are many different demands or things that are asked of waterways or asked of hydroelectric power plants and where they're located, such as recreation, wildlife. The Commission has to weigh all of these various things. There's also a comprehensive plan that's usually developed where, local entities or the state come up with a plan of saying, how does this waterway or how does this hydroelectric plant fit into our long-term development goals? That's something that FERC also has to balance when it's kind of analyzing the license or the relicensing of a plant. There are also, of course, state and federal Fish and Wildlife Agency recommendations. So FERC has to pay attention to a lot of rules and regulations surrounding wildlife and conservation. And it has to also maintain consistency with a lot of these plans that are developed at the state and local level. So there are a lot of things that FERC has to analyze and also be held accountable to when analyzing these licensing procedures. And here's just a bunch of other statutes. So it has to also manage and analyze these licenses through all of these kind of other federal acts related to conservation and wildlife management. And so for those of you who are familiar with the Pensacola Dam, these kind of bigger issues aren't probably surprising, but these are typical environmental issues analyzed under NEPA analysis, which is the typical environmental analysis that a lot of these licensing processes take place. So fisheries, wildlife, general aesthetics, recreation, terrestrial concerns, cultural and tribal, and water quality. FERC also has other considerations that it tries to balance when it's, kind of doing its decision-making around these hydroelectric plants, things such as flood control, unsurprisingly, water supply, navigation, irrigation, and energy, things that for some reason, I believe in the regulatory language, it calls developmental concerns, oddly enough. I think it's trying to talk about these kind of broader things besides environmental concerns that are factored in. FERC hydropower overview. So when FERC does kind of analyze these projects again, as I was saying, it has to give equal consideration to environmental, recreational, cultural, and developmental resources. It has to provide assistance to and foster coordination among applicants and stakeholders. So you typically have an applicant. So in this case, in the Pensacola Dam, it's GRDA. So GRDA is the applicant, and when it does its relicensing, it has stakeholders, I believe probably many of you in this room, who it has to consult with, and it has to balance a lot of these kind of other concerns and demands on the hydroelectric plant with what the applicant is contending. FERC also prepares and issues NEPA documents and ensures compliance with the terms of commission licenses and exemptions during construction operation. And it also ensures the safety of non-federal hydropower dams. Besides this whole, the licensing of dams, there's a whole division in FERC that actually just goes out and inspects dams and makes sure that they're safe for recreational use, that they're safe in terms of also what the licensee says when it got the license from FERC. There are certain requirements that it has to abide by. And FERC goes out into the field and goes to these plants and visits and makes sure that those terms are being respected. And kind of getting to what I was saying in terms of the licensee and applicant. So licensee, who is the applicant and also the stakeholders, FERC, has to deal with these, a suite of different people. So the licensee, but also different resource agencies, different state and local resource agencies, tribal agencies as well, or tribal agencies and communities as well. FERC has non-federal or federal to federal relationships and consultation with tribes, but it also has to take into consideration, state tribes who are kind of in a different category in terms of how the federal government consults with tribes, but they're still equally important in terms of how FERC has to take into consideration their concerns in the licensing process. There are, of course, also local stakeholders and other non-governmental organizations involved in the process as well. And also just to provide another perspective on FERC, so we have the Office of Public Participation, but you have the Division of Hydropower Licensing, so they are in another office and they're divided in different regions. Because there are so many different hydroelectric power plants in the U.S., that office has different regional responsibilities all over the United States. And so that office that's the main office, that's staff, where staff are located, and they're the staff that are doing all of this work and licensing on these hydroelectric plants. And so you can kind of see through this map, you have like the Northwest region, the Western region, the Southwestern region, the Midwest branch, which I believe actually today is divided up with a Great Lakes component. And then you have two other branches in New England and the Mid-Atlantic region. And so just to provide a summary of the different kinds of authorizations, again, in the case of the Pensacola Dam, it's coming up with a relicensing. So it had already received a license, but that license terms is up. So it needs to go through a relicensing process. FERC also does a thing called preliminary permitting. So, it gives companies the right to apply for a permit where they can be kind of like the first mover in a place in the U.S. If they decide that a particular place looks ideal to construct a hydroelectric dam, FERC will issue them a permit, and they have a fixed set of years. I believe it's 4 years in this case, where they're able to kind of prospect the area and see if it's suitable for their purposes. Within that time, if they don't find that it's suitable to construct a dam, they can give up that permit, and then somebody else has the right to construct a hydroelectric dam in that location. So kind of to circle back to our office, and how does this all fit together for a lot of the folks in this room? So our office was created to provide a lot of the regulatory assistance with these processes. For hydroelectric projects in particular, it's very stop and go. There are many different periods of participation and input in the process. And so if you're someone who doesn't pay attention to the Federal Register like I do, that can be very difficult to know when you can get your say in and have your studies or your data or your perspectives put on the public record. So our office was created precisely to assist people and literally hold people's hands in terms of trying to get that information on the public record. Just to take a step back to, we operate in terms of like an administrative record where we have a project such as the Pensacola Dam. And all of that information and studies that the public has, it's most taken into account when it's put on the public record. So if you don't get that information on the public record, then it's very difficult for FERC staff to have that information that's being studied or provided or analyzed to factor that into its decision making when it's trying to weigh all of these different things for a project. We also do a lot of enhanced outreach and expanded notice. So for a lot of these projects, if you're familiar with, if you're following the Pensacola Dam project, you might be aware that the licensee, GRDA, has to notify certain folks about the project when it's making moves and wanting to relicense or making a certain step with the project. There are certain regulatory requirements, but I think, so our office kind of disagrees with those requirements where, you know, a certain set of people within a, you know, a certain radius around the dam might be affected, but there might be other people outside of that very narrow radius that the company contacts that we think are really important still who need to be contacted. So we do a lot of expanded outreach where we try to find communities and NGOs and different organizations who would have a say but might not be involved because that company didn't reach out to them because it was following a very narrow definition of who is affected by a project. Similarly, we deal with a lot of projects that are actually in communities where English isn't the first language. We do a lot of outreach, not just in Oklahoma, but in the Gulf Coast, where there are a lot of Vietnamese communities and a lot of Spanish-speaking communities. And we try to tailor a lot of the information we provide to folks based on those communities' preferred languages, which has been really appreciative because they can participate better if they actually have that information in their language. We also do a lot of educational materials. I think until, especially for someone who previously worked at FERC, I'm shocked now having the perspective of working in my office where I think that our agency has just done a really poor job in terms of explaining itself and providing information to people and not being the most transparent that it could be and explaining, you know, its role in different aspects. So our office has actually kind of taken that lead and tried to provide more materials for different things that our agency does. And you know, after this talk, I'm happy to hear if you have any suggestions on what we could provide. We love to make things tailor-made so that they can be as useful as possible to people. And similarly, we do a lot of community engagement, trying to find folks, again, who are affected by projects but might not be captured by simple definitions or definitions that are utilized by a company when it's carrying out the basics for a project. And kind of last thing that I mentioned, we do a lot of work for internal change at FERC. A lot of our colleagues are, you know, come from a similar perspective, have worked at the agency for a very long time, so they're used to simply doing things in a certain way. And I think our office has a really big role in terms of trying to push for change and saying like, hey, you need to really reach out to people. If you really want a good record and really good information to make a decision, you need to do the outreach, you need to talk to communities. So that's something that our office also does at FERC. So getting more specific to how can our agency help, for anyone who's interested in the Pensacola project or has any other kind of projects that FERC is associated with, we will partner with you to figure out all of the procedural and participation information necessary to participate effectively in a given case. Sometimes it takes years for certain things to happen at FERC, and in that process things can get lost on the way. There might be meetings or public input opportunities, and we want to make sure that you have all of those opportunities so that the information you have and the perspectives you have can get on the record so that staff can take that information and use it when it's evaluating a project. Similarly, we want to be a resource for federal, state, regional agencies, NGOs, and utilities companies on conducting research. Again, going back to the concept of expanded notice, you know, going beyond what's required and really trying to kind of be that anthropologist in the field and figuring out, you know, who are these communities that are really affected by something or who have like a very important thing to say that needs to be captured in our administrative record. Also, we do a lot of workshops and just educational materials that can be found on our website. We also are very happy to mail those things. I think a lot of folks still appreciate hard copies of things these days, and we are happy to send those things to folks because we know that not everybody has the internet, not everybody likes to, you know, consume information from the internet, so we're also happy to send that to people. And we are very big on constituent services, so we actually have a hotline where you can call us about anything related to FERC or not. We'll untangle the question for you and try to figure out if it's FERC related, we'll point you in the right direction at FERC. If it's not FERC related and might have something to do maybe with like your local government or your state agency, we'll still try to point you in the right direction so that you have a good landing place to find your way. So again, kind of going back to the key elements for participating at FERC. Number one, I can't emphasize this enough, is getting in contact with our office and really being aware of opportunities to provide public comments. So this is not common. This isn't just a thing at FERC, but across regulatory agencies in the federal government. So every day the government issues regulations in the Federal Register. Again, it's hard for anyone citizen, even myself who works at FERC, to follow the Federal Register and find all of the different regulations that I could, provide information for. But those are really important opportunities if you're a scientist and are doing a study on soil, or if you're a hydrologist and have research on hydroelectric plants. That's really important information that you could provide to the public record that could really impact decision making that staff is trying to deal with at FERC. Again, attending public meetings. So for hydroelectric projects in particular, there will definitely be public meetings coming up. The relicensing, again, I think is not until 2025, but I believe a scoping meeting has to take place. So that's the kind of the first part where you can go and the licensee has to explain itself and justify itself and say, why does it believe that it deserves to have to be relicensed by FERC? And also how it plans on following through with a lot of the requirements required by FERC to get its license. And last to note, you can also become an intervener in a proceeding. This is more of a kind of an administrative thing, which if you're interested, please ask me. It's if you want legal standing in a case. So if you disagree with FERC on its decision, if you define yourself and apply as an intervener, that means that later on when that proceeding goes to court, when that case goes to court, you have legal standing to challenge that decision. So it's a really handy thing if you do think something's not going to go your way, but it also comes with certain responsibilities that I'm happy to talk about after this talk. So again, just to kind of summarize again, get involved in a case early. I'm really happy to talk with you today because the relicensing is coming up, and it actually isn't too early to start getting involved and start planning how you would participate in that proceeding. Stay informed. So we have a little thing called eSubscribe on FERC's website, which I'm happy to show people, which is basically kind of like if you're on a website, it says, apply to this newsletter because we want you to stay informed about our organization or agency. Very similar, it will provide you with updates very specific to that project that you want to follow. So if you're interested in the Pensacola Dam, it has its own project number, which I'm happy to provide for everyone. And if you register for that project number, you will get constant updates with any movement or updates on that proceeding. Again, participate in meetings and studies when they're announced. Again, that will be announced through eSubscribe based on that docket that's going on at our agency. Review documents, and again, not just to be a little redundant, but file comments with FERC. We really need your voice on the record. That's a fantastic opportunity, again, if you're a scientist or an academic or a community member with a certain perspective or research. You can get that research and a lot of that evidence that you're collecting as part of your job or role in the community on the record so that staff have that information and they can put it into their decision making. And so we have a number of kind of underpinning a lot of the things that I said, like eSubscribe or filing comments. A lot of those kind of ways to participate are supported by different electronic systems at FERC. That's another reason why our office exists, to help people navigate all of these electronic systems, which I'm happy to do for folks if you have any questions after this talk. We also have a lot of different resources. We have a hydropower page at FERC, which also contains a hydroelectric primer. So it goes over all of the different things that FERC is in charge of in terms of hydroelectric power, the different review standards that FERC has to follow, and that that FERC needs to be held accountable for when it reviews hydroelectric projects. We also have our Office of Public Participation page, which contains a lot of the educational materials that I mentioned. And I will be here for dinner and most of tomorrow, so very happy to talk, and thank you.
Comments can add up to, like if you're licensing, if FERC is a licensing agency, then they should periodically say, no, you haven't done enough. So, yeah, what does that look like?
Yeah, so I actually, and this is not to say that it hasn't happened, I come from a different office, so I'm actually not familiar with cases where FERC hasn't relicensed the project. I'm not saying that it hasn't happened, but I'm personally not familiar with it, but I could find you that information if you wanted. And I think there are cases though where it doesn't just come to FERC saying like, yes, you're licensed, or yes, you're not licensed, or relicensed. I think there's different things that can be changed along the way prior to the approval of the relicensing.
Sure.
So,
Yeah, but I mean, it'd be interesting to know that a certain percentage, you know, like it does happen.
It does happen, yeah. And I can definitely follow up with you if I get your name after this with that information.
So, first off, really glad that your office exists, but since you haven't been there that long, I don't know how established this is or how well you'll be able to answer this. But I just finished my thesis research on community involvement in the superfender mediation process and how that affects environmental justice efforts, and I've looked a lot at the EPA's Office of Environmental Justice and like examining how that process works in the remediation, and I feel like this like is a mirror of that for the energy sector. But with environmental justice, as much as there's like a push for it, it's not like a mandated part of the process, and I feel like your office is like reactive to a messed up system that doesn't necessarily like include formally community input, and I feel like that complicates things a lot, even though it's a bridge between this regulatory system and the community, and you guys are offering a service. But thinking about like the millions of people around the country who are impacted by FERC's decisions, how do you make sure that your services are distributed equitably, and how like it's not like in communities like this where there's a community advocate like lead agency making sure like your services are fully implemented here, like how do you get that information to communities who wouldn't know to ask?
Yeah, so that's a really great question, and I think a lot about those things, especially because I also think of, you know, instances where federal agencies don't have an Office of Public Participation. Not saying that we're the best solution to the problem of, you know, lack of transparency at FERC and ongoing issues. So our office so the main ways we do that, so we've scattered people across the country, so we intentionally have people regionally established across the United States. So I actually have one of my employees based in Oklahoma City, which I was going to include a slide on her and actually like circle her and be like, you need to contact her. But she's basically in your all's backyard and covers this region. And so she's there. We hired her with the intention of being an on the boots kind of person to go out to communities, and you know, if we become aware of either through our own efforts or our community notifies us of something that's going on, she can go there and be a human being on the ground to take a look at what's happening, and then she'll bring that back to FERC, and we hopefully get a lot of that information that staff at FERC aren't seeing, you know, at least for their awareness. So I think that's the main innovative approach I think we've taken that I'm the most proud of, is like intentionally saying like we need staff around the country who are federal employees who can be there if you ask them to come to your community and take a look and talk to you or to explain FERC things. We also, kind of going back to expand and notice, it sounds very bureaucratic and regulatory, but I think it's very important. So we spend hours researching projects and trying to be, as I told my colleague, kind of like anthropologists, where we go into communities and kind of we drive there and try to find churches, local newspapers, local NGOs who, you know, again, might not be contacted or aware of something, but because we've identified them as even just potentially affected or potentially able to participate, we'll put them on a list and contact them. And call them and say like, hey, you need to be aware of this. And, you know, based on our knowledge of your organization, this is something that you could usefully provide to the public record to get it before the FERC staff evaluating that project. So I would say those are the two main ways. We're also a very small office. So we have about 15 staff, which might sound like a lot if you come from a small organization, but we're covering the whole United States. So it's actually not a lot. But we have big hopes.
when you mentioned dam safety, for example, right? And you could translate this to safety of high voltage power lines, but dam safety is a perfect example because, well, both have national security implications potentially, right? And so there's a tension that I see between, on the one hand, the need to maintain some degree of confidentiality about some of these dam safety reports or, you know, power line safety reports, right? And then on the other hand, you have the public engagement and the need of stakeholders to be able to speak intelligently about these licensing and relicensing related issues. And I'm wondering if you could say a little bit about what is the realm of possible for the public to assess some of these critical safety issues where, in particular, the licensee or the operator may have the greatest incentive to hide problems?
That is a very tricky question. That is very tricky because also, of course, speaking for my own views and not on behalf of the federal government, the utility sector is just very known to, you know, have a lot of these security issues and concerns, but they will do everything to not put that information out there for the public. And so and I think you make a great point. I think it's very hard for the public to assess because all of that information is locked up and it's not provided.
So basically, it's all under lock. It's all filed essentially under seal at FERC, and it's simply not publicly available.
So
Is that kind of the bottom line?
My understanding, so I think it's again these kind of halfway things you see from the government, from FERC, and I guess from the government I could generalize. But you know, they'll release like in your case, in the example you gave of dam safety reports, they will release certain reports, but it won't contain all of the information. And so there is information that's, you know, aided in that staff decision making, but that information isn't always completely publicly available.
So one thought following up on that I think would be an incredible service for folks providing the future would be, and I think, you know, I've spoken with other people in your office a couple times on the phone, but, you know, using the task model which is the fun, right?
Mm-hmm.
As an analog where they interpret technical documents to us. Well, one of the things that also happens there that could be a unique feature at FERC is when you do have things that are partially published, you know, partially redacted, to help the public find out how to ask questions about that, right? To essentially help the public understand, is there a there there? Is there something that may be hidden you need to be concerned about? Or, given their specialized knowledge, can you say, you know what, this is not something you probably don't need for.
Yeah. I think that's great. Yeah, as a previous staff member who was completely bothered by all of these documents that were redacted, so just to explain for folks, there's a lot of public information that goes out there, not just from our agency, but a lot of government agencies, and you'll see that a lot of times, especially if you're providing information that was provided by a company, you'll see that that information was just blacked out. And there's always not sufficient explanation, at least in my opinion, of why it was blacked out. And like, I think to your point, Martin, is like, why was that important? Was it not important? Were they just like, in our case of being an energy agency, companies will black out information because they think it would harm their competitive position in the market, which is, you know, that might be like harmless. It might be just relative to your position as like, you don't want your competitors to find out your secrets, is a classic example. But was there something else at stake? And it's not always known for the public to figure out if that was, you know, something important that they should be paying attention to. Yeah. 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 But we've actually, our office has, because our office is made up of a lot of staff who came from those offices and reviewed those documents, we've actually, we basically escalated that issue to an extent and tried to ask, you know, why, to what extent can we let this kind of happen? So.
One phrase in one of the slides that really caught my attention was equal consideration across all variables, from variables as diverse as cultural to wonder, how do you know you're achieving? And so one, is there a metric that you use, or is it aspirational? And two, the data you need to collect to achieve equal consideration is so different across those fields. So I wonder if you could speak to that.
So I think you hit on a good point. That's a really good critique of.
Could you repeat the question, please? I'm sorry.
Yeah, so I can kind of paraphrase your question. So in a previous slide, I talked about how in hydroelectric licensing, there's a term in the regulatory requirement which is called equal consideration. So you have, when you're doing relicensing and trying to evaluate a project, you're looking at a bunch of different factors, such as environmental factors, or how, recreational factors, things like flood control. And it's FERC's responsibility to, quote, provide equal consideration of all of these factors. And I don't know if this is the exact, I don't want to, missay what you're trying to get at, but I think it is very fuzzy in terms of what that actually means. And I think that it's on a project by project basis of what that means for a given project. And I don't think that's a satisfactory response, but I think from kind of observing some of the hydroelectric projects that FERC has done, I think that's the approach it has taken, while still saying that it treats these projects as under equal consideration. Yeah, I don't find the definition. Yeah,
not very satisfying.
It is not very satisfying. I completely agree. All right, yeah. Oh, and thank you for letting me go after Rebecca's film. It was very hard to go after.
Yeah, Martin, you want to explain?
Sure.
Yeah, okay.
Okay, folks. One of the things that we like to do is ask you to not just be observers, but to be participants. And how fitting it is to say this with someone from the Office of Public Participation here. So you may recognize our postcards with a picture of the flood map. These are chat piles. And they are pre-stamped, pre-addressed to FERC. And if you want to write a short message to FERC about the Pensacola Dam relicensing, or about flooding, or about your hopes for a better Office of Public Participation, Rebecca is passing some out. I'm going to pass out on this side of the room, but please take a moment and fill out one of these, leave them. You don't need to put your name, but it would be greatly, greatly appreciated.
Okay. But remember, this is the only federal agency that can help us. So in your thoughts, keep that in mind. These are our friends. We believe in them. Okay.
Yeah. But do take FERC to task.
Yes, be pushy. Yes, you need to be. Yeah. I do want to tell you that every day postcards and letters are going into FERC, and they have a website. And on their website, they publish them. So you can go back in and make sure your cards got posted. Make sure they got them turned the right side up. You'll see your friends. Your friends are all writing. Your neighbors are writing. Their children are writing. The people around the country are writing, and they're going to keep writing. We've got something to say. And what's that number?
The docket number, which you can put on the postcard, is P as in Paul, -1494. And that's the docket for the Pensacola Dam. Yep. P as in Paul, -1494. I feel like I'm reading bingo letters. So yes, lots about FERC and about flooding and about the dam today. And I guess now we're going to shift gears again.
We're doing it.
Yeah.
Yeah, shift.
So, I know, do we have an update on the fish?
Well, it isn't fish, it's tacos.
Oh, it's tacos, that's right, fish is tomorrow.
Right.
Okay, yeah, Indian tacos, and they're on the way. Yeah, so everybody just stretch your legs. I encourage you, turn around behind you. Talk to the person behind you. Talk to someone you haven't talked to yet, right? Because we all want to get to know one another. So just hang out for a few minutes and we'll come back when we've got food to talk about.
It's coming, and plenty of it. So if you leave without eating, you'll have dishes to do at home. So just stay.